Chapter 1 of On Sensation and the Sensible in Parva Naturalia. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Jeffrey Edwards. Parva Naturalia by Aristotle. Translated by William Alexander Hammond. On Sensation and the Sensible. Chapter 1. Now that we have treated of the soul in its essential nature, and of the faculties that belong to it, part by part, our next duty is to investigate the subject of living creatures and everything that has life, to determine what functions are specific and what functions are general. Let us then take what has already been said touching the soul for our basis, and as we proceed to the remaining inquiries, let what is first by nature be first in our discussion. The most important vital phenomena, whether one regards the specific or general attributes of animals, are those which are the joint concern of soul and body, such as sensation, memory, anger, desire, and impulse in general, and, one may add, pleasure and pain. These are experienced by almost all animals. In addition to these, however, there are other attributes which are common to all animals that share in life, and others still that belong only to certain animals. The most important of the former class may be enumerated in 4 pairs, viz., sleeping and waking, youth and old age, inspiration and expiration, life and death. We must study the nature of each of these phenomena and the causes of its occurrence. The investigation, too, of the ultimate principles of health and disease is the province of the naturalist, for neither health nor disease can apply to creatures when deprived of life. And so it happens, as I think, that most natural philosophers and those physicians who have a more philosophical understanding of their science conclude in the one case with the investigation of medicine, and in the other begin their practice with deductions from the laws of nature and their application to medicine. The above-mentioned phenomena are evidently the common property of soul and body, for they are all conjoined with sensation, or are mediated by it. Some of them are modifications of sensation, or persistent conditions of it. Others are protective or preservative of sensation, while others still are destructive and negative. That sensation is mediated by the body to the soul is plain, both with and without the use of rational proof. However, regarding the essential nature of sense perception, and the reason why animals are endowed with it, we have already stated our views in the treatise on the soul. Every animal, in so far as it is a living creature, must have sensation, for it is in terms of this that we distinguish between animal and non-animal. Touch and taste must belong to all animals individually. Touch for reasons given in the treatise on the soul, and taste on account of food. For it is by taste that animals discriminate between agreeable and disagreeable in foods, and so reject the one and take the other. In a word, flavour is an affection that belongs to the nutritive soul. Sensations that are excited by external objects, such as smell, hearing, and vision, are found in animals capable of locomotion, and are given to all of them for the sake of their preservation, in order that they may scent their food and pursue it, and flee from what is harmful and destructive. In the case of animals endowed with intelligence, they are given for the sake of higher well-being, for these sense perceptions convey to us various distinctions, out of which the knowledge of intellectual and moral concepts is built up. Amongst the senses, vision is the most important, both in itself and for the necessities of life. On the other hand, for the uses of reason, and accidentally, hearing is the most important. The power of vision informs us of many and various distinctions, because all bodies are suffused with colour, so that by means of this sense, more than by any other, we perceive the common properties of objects. By common properties I mean form, magnitude, motion, number. Hearing, on the other hand, informs us merely of distinctions in sound, and in some instances of distinctions in articulate voice. Indirectly, however, hearing contributes the greatest share to our intellectual life, for it is the spoken and heard word that is the source of knowledge, and hearing is the source not in itself, but accidentally. Language is composed of words, and every word is a symbol. This explains the fact that in cases where men are deprived of one or the other of these senses from birth, the blind are more intelligent than the deaf and dumb. Chapter 2. We have already treated of the function of the several special senses. Writers nowadays attempt to correlate the senses with the physical elements as found in the bodily members in which the sense organs have their natural development. With the fifth sense they are hard-pressed, not finding it easy to pair 5 senses with 4 elements. All of them agree in regarding vision as connected with fire, on account of a certain phenomenon whose nature they misunderstand, viz., when the eye is pressed and moved it seems to scintillate. But this takes place in the dark, or when the eyelids are shut, in which case darkness is produced. And there is also another difficulty here. For if it is impossible for a perceiving and seeing subject to be unconscious of a seen object, then the eye must necessarily see itself. Why, then, does this not take place when the eye is at rest? The explanation of this phenomenon, as well as the solution of the entire difficulty and of the apparent fact that vision is fire, is to be found in the following considerations. It is the nature of smooth surfaces to shine in the darkness, although they produce no light. Now, we observe that the dark central portion of the eye has a smooth surface. This becomes apparent when the eye is moved, because the single organ is thereby made double, an effect which is produced by the rapidity of the motion. In this way, the seeing organ and the seen object appear to be different. For the same reason also, this effect fails to be produced when the motion is not rapid and does not take place in the dark. For it is in a medium of darkness that a smooth surface naturally shines, as we see in the case of the heads of certain fishes, and in the juice of the cuttlefish. The consequence is that when the eye is moved slowly, the seeing organ and seen object do not appear to be at once unitary and dual. When, on the other hand, the movement is rapid, the eye sees itself as in the reflection of a mirror. Now, if vision were fire, as Empedocles declares, and as we read in the Timaeus, and if seeing resulted from the passage of light out of the eye, as from a lamp, the question arises, why is it that we do not see in the dark also? To say, as the Timaeus does, that the light when it passes out from the eye is extinguished in the darkness, is a totally empty assertion. For what is meant by an extinction of light? The warm and the dry, it is true, are nullified by the moist and the cold, as one sees in the case of a coal fire or a flame, but neither of these has anything to do with light. If, however, they are attributes of light, but are concealed from us owing to their subtle presence, then light ought to be extinguished in the day during rain, and darkness should increase in frosty weather. Flame and ignited bodies are so affected, but nothing of the sort takes place in the case of light. Empedocles appears to hold the view that vision results from the eye's radiating light, as we said before. His own words, at any rate, are as follows. Quote, as a man taking thought for his journey a lantern prepares, whose flame flashes light through the blustering night, as he passes, and shutters he fastens, defence from winds, to scatter the breath of the blowing blasts, while the light pierces through, by its fineness, and gleams over the threshold unfailing. So of old, fire elemental was fixed in membranes, and suffused the round pupil, held in thin tissues, a check to the water, while the fire pierces through by its fineness. Sometimes he gives the above explanation of vision, and at other times he explains it by means of emanations from visible objects. Democritus says that vision is due to water, and in this he is right, but he is wrong in thinking that it consists in reflection, for reflection is produced because the eye is a smooth surface. Vision, however, does not take place in this smooth surface, but in the seeing subject. Now, the condition to which he refers is only a reflection of light. He has, however, as I think, no clear idea whatever concerning the general nature of images and reflection. It is also strange that it never occurs to him to raise the question why it is that the eye alone sees, while no other object in which images are reflected has vision. His statement that vision partakes of the nature of water is true, but vision is not due to the fact that the eye is water, but to the fact that it is transparent, which characteristic it has also in common with the air. Water, however, is easier to fix and is thicker than air, and it is for this reason that the eye and its pupil are composed of water. This can be proved also from actual facts. When the eyes are destroyed, water is seen to flow out of them, and even in their quite embryonic stage, the eyes are exceedingly limpid and brilliant. Further, the white of the eye in sanguineous animals is fat and oily, which serves the purpose of keeping the humid element from congealing. Consequently, the eye can resist cold better than any other organ of the body. No one ever experienced the sensation of cold in the interior of the eye. The eyes of bloodless animals are covered with a hard skin, which furnishes protection. The theory is altogether irrational which makes vision consist, as some hold, in a sort of radiation, and regards this radiation of something from the eye as extending to the stars, or as extending to some point, and there effecting a combination with the object. It would be better to assume that this combination of the eye with its object were in the eye's original nature. But even this is nonsense. For what is one to understand by this combination of light with light? Or how is such a thing to take place? For nothing combines in a haphazard way with anything else. Further, how can the internal light combine with an external one? For between them is the intervening membrane. Regarding the fact that there is no vision without light, we have spoken elsewhere. But whether the intervening medium between the visible object and the eye is light or air, it is in any case the motion through this medium that produces sight. And it is reasonable to regard the interior of the eye as composed of water, for water is diaphanous, and as nothing external is seen without light, the same thing applies to the internal. The internal also must, therefore, be diaphanous. Since this diaphanous is not air, it must be water, for the soul or the perceptive power of the soul is not found on the eye's surface, but evidently within. Consequently, the eye's interior must be diaphanous and sensitive to light, and this we can see empirically. For cases have happened in war where persons have received such a blow across the temples that the ocular conduits were severed, and darkness seemed to ensue, just as when a lamp is put out, and this is due to the fact that the diaphanous, i.e. the pupil as we call it, was cut off, as in the snuffing of a lamp. If, therefore, this takes place in some such way as we describe, it is evidently necessary to render an explanation of this kind, and to correlate each sense organ with one of the elements, viz. The seeing power of the eye we must derive from water, the sense for sound from the air, and smell we must associate with fire. For the organ of smell is potentially what smell itself is actually. The sensible object stimulates the sensation into actuality, and consequently the latter must have an antecedent potential existence. Smell is a smoke-like exhalation, and this is derived from fire. It is for this reason, too, that the organ of smell is especially assigned to the environment of the brain, for the material substrate of cold is potentially warm. And the same explanation holds good for the development of the eye. It is formed from a part of the brain, for the brain is the moistest and coolest member of the body. The organ of touch is derived from the element earth, and taste is a form of touch. Consequently, the organs of these two senses, taste and touch, are found to conduct towards the heart. The heart occupies a counterposition to the brain and is the warmest member of the body. Regarding the sense organs of the body, let the above determination suffice. End of chapter 2. Recording in memory of Mitchell Edwards. Chapter 3 of On Sensation and the Sensible in Parva Naturalia by Aristotle. Translated by William Alexander Hammond. This LibriVox recording is in the public domain. Recording by Geoffrey Edwards. Chapter 3. In the treatise On the Soul, I have given a general account of the objects of sense in their application to the several sense organs, such as colour, sound, smell, flavour, and the tangible. I have explained their function and their activity, organ by organ. But we must also determine what each of these things is apart from the organ, e.g., we must ask, what is colour? What is sound? What is smell? What is flavour? We must likewise inquire regarding the tactual, and we must begin with colour. Everything has a twofold significance, viz., that of actuality and potentiality. It has been explained in the treatise On the Soul in what way actual colour and actual sound coincide with and differ from the actual sensations of seeing and hearing. We must now explain what each of these sensible objects must be in order to produce sensation and its activity. We have already said in the above-named treatise regarding light that it is the colour of a diaphanous medium accidentally produced. For when anything fire-like is found in the diaphanous, its presence constitutes light, and its absence signifies darkness. What we understand by diaphanous is not a property peculiar to air, or water, or to any other so-called body, but it is a certain natural constitution and power common to both these bodies, and found also in certain others in greater or less degree, but which has no independent and separate existence. And furthermore, as there must be a limiting surface in bodies, so here also. Light is found in an indeterminate diaphanous. It is also evident that the diaphanous in bodies must have a surface, and that this surface is colour is plain from observed facts. For colour is found either in the boundary, or it is itself the boundary. It is for this reason that the Pythagoreans characterized the visible superficies as colour. Colour indeed is given in the boundary properties of body, although it does not itself constitute that boundary. On the contrary, one must suppose that the same colour quality which is observed on the exterior applies also to the interior. Both air and water are seen to be coloured, for even their shimmer is colour. In these cases, however, air and the sea, because of their unfixed character, do not have the same colour when viewed near at hand and from a distance. In solid bodies, on the other hand, the appearance of the colour is fixed, unless the surrounding medium makes it shift. It is evident, therefore, that the principle which is sensitive to colour is, in both the former and the latter instances, the same. The diaphanous, then, in so far as it is found in bodies, and it is found more or less in them all, causes them to be saturated with colour. inasmuch as colour is found in the boundary of bodies, it would also be found in the boundary of the diaphanous substance. Consequently, colour might be defined as the boundary of the diaphanous in a definite body. Colour attaches also to diaphanous bodies themselves, such as water and other similar elements, and it is also found in all such bodies as have a surface colour which is peculiar to the body itself. There is then, on the one hand, the possibility that the positive principle which in the air produces light should also be contained in the diaphanous. On the other hand, it is possible that this should not be the case, but that the condition then should be one of privation. As in the case of air we have the two phenomena, light and darkness, so in bodies we have the two qualities, white and black. Regarding the other colours, we must now decide, after analysis, in how many ways they can be produced. For black and white may be so juxtaposed that each of the two, on account of its minuteness, when taken alone, will be invisible, while the combination of the two will be visible. The latter cannot be seen either as white or black. But inasmuch as it must have some colour, and it can be neither of these two, it must be a mixed colour, and different in kind from the others. It is then a possible supposition that there are several colours besides white and black, but their manifoldness is due to proportion. This proportion can be expressed by the relation of 3:2, or of 3:4. Or colours can be related to each other in terms of other numbers, and some may not be expressible at all in terms of any proportion, but in terms of some incommensurable plus and minus. The same thing applies also to harmony of tones. Those colours which are expressed by harmonious numbers, as is also true of tone harmonies, appear to be the most pleasing, such as sea purple, crimson, and a few others like them. They are few for the same reason that harmonious tones are few. The other colours are not numerically expressible. Or is it true that all colours are numerically expressible, although some colours depend upon a regular order, while others depend upon an irregular order, and the latter have this character when they are not pure? This is one explanation of the genesis of colours. Another explanation is that they shine through one another, as we see sometimes in the works of artists when they superadd a colour on a background of a different colour, e.g. when they wish to produce the effect of an object seen in the water or in the air. So it is also with the sun, which in its own nature appears white, but red when seen through mist and smoke. And many other colours will be produced in the same way as above described. That is to say, a certain proportion might be supposed to exist between the colours on the superficies and the colours in the depths, and others again may not be expressible in terms of proportion at all. It is therefore absurd to say with the ancients that colours are effluxes, and for this reason are visible. For in their opinion it is absolutely necessary that sensation be effected through contact, and it is consequently better to say at once that the medium of sensation is set in motion by the sensible object, and that in this way sensation is produced by contact and not by effluxes. In the case of juxtaposed colours, just as one must suppose an invisible magnitude, so must one suppose an imperceptible moment of time in order to explain the fact that the movements issue imperceptibly, and because they are simultaneously visible, the impression is a single one. There is, however, no such necessity here, but the colour on the superficies, when unmoved, and when set in motion by its substrate, produces unlike motions in the medium. Consequently, it appears different, and neither white nor black, so that if an invisible magnitude is not possible, but every magnitude must be visible from a certain distance, so there must be here also a certain mixture of colours. In this way, one may suppose that in objects viewed from a distance a certain common colour is seen, for that there is no invisible magnitude is a matter that must be investigated later. If a mixture of bodies takes place, then it is not merely in the way that some think, viz. By the juxtaposition of minimal parts which are imperceptible to our senses, but also in the form of a general mixture of the entire substance together, as explained in outline in our treatise on mixture. By the former method of composition only those substances can be mixed which are capable of analysis into minimal parts, e.g. men, horses, or seeds. In the case of men, a man is the minimal part. In the case of horses, a horse. Consequently, in both instances, the mass is formed by juxtaposition of these minimal parts. We do not, however, speak of a man being mixed with a horse. Whatever cannot be analysed into minimal homogeneous parts is incapable of mixture in this sense, but only in the sense of total mixture, which is what naturally takes place in most cases. In our treatise on mixture, we have already explained how this can take place. Where bodies are mixed, their colours must evidently be mixed also. And this is the principal cause of the multiplicity of colours, which is not explained by their being superposed or by their juxtaposition. It is not true that what is mixed has one colour when viewed nearby, and another when viewed at a distance, for it has one colour when viewed from all points. And colours will be manifold because of the possibility of manifold proportions being employed in mixtures, some of which will be based on numerical proportion, others on that of disproportionate mass. Further, the same thing may be said of mixed colours as was said of juxtaposed and superposed colours. The explanation of the fact that we have fixed and definite varieties of colours, flavours, and sounds will be given later. Chapter 4. We have now explained the meaning of colour and the cause of its multiplicity. We had already discussed the subject of sound and articulate speech in the treatise on the soul. Smell and flavour now remain to be discussed. Both these terms signify almost identical natural affections, only each of them is found in a different organ. The quality of flavours is more distinct to us than that of smells. The reason is that our sense of smell is inferior to the same sense in other animals, and is inferior to all our other senses, while we of all animals have the most accurate sense of touch, and taste is a sort of touch. Water in its own nature has no flavour, and yet it is necessary that water should contain within itself the varieties of flavours, which, owing to their infinitesimal character, are indiscernible, as Empedocles says, or else there must be in water some such matter as is the universal germ origin of flavours, and in this way all flavours are generated out of water. Different flavours from different parts, or again, supposing that water contains no qualitative differences, we must then find some other efficient cause of flavour, such as heat, or the influence of the sun. The error of the Empedoclean theory is very easy to detect, for we actually observe flavours undergoing change under the influence of heat, e.g. when we expose fruits to the sun by removing their pericarps, or by heating them before a fire. They do not acquire this new flavour by drawing it out of the water, but by undergoing a change in the removal of the pericarp itself. When fruits are dried and stored, they become in time, instead of sweet, pungent or bitter, or change their flavour variously, and when cooked, they acquire, so to speak, all sorts of flavours. So too, the theory that water is a panspermic matter is impossible, for we observe that out of one and the same thing, as out of the same foodstuff, different flavours are generated. There remains the theory that water by undergoing some external influence changes. It is plain that the phenomenon which we call flavour is not due to the potency of heat. For water is the thinnest of all liquids, subtler than oil itself. Oil, however, is more expansile than water because of its viscous character, water being non-cohesive. For this reason, it is harder to hold water in one's hand than it is to hold oil. Now, since water is the only liquid which, when heated, exhibits no denser consistency than before, we must evidently look elsewhere for the cause of flavour, for all flavours are more dense when heated. Heat is a contributing cause, not the sole one. Apparently, the flavours that are found in fruits have a prior existence in the earth. In the same spirit, many of the ancient physiologers say that water is like the soil through which it passes, and this is particularly evident in the case of salt waters, for salts are a form of soil. Also, water that has been filtered through bitter ashes acquires a bitter taste. Further, we often find springs that are bitter and others that are pungent, while others still have different flavours. The greatest variety of flavours is found, as one might suppose, amongst plants. It is the nature of moisture, as of other things, to be affected by its opposite, and its opposite is the dry. Consequently, it is affected by fire, which is by nature dry. Now heat is the peculiar property of fire, and the dry is the peculiar property of the earth, as was said in the treatise on the elements. Neither fire, nor earth, nor any other element, as such, acts or is acted upon. It is only in so far as each thing contains in itself the principle of opposition that it either acts or is acted upon. As, therefore, those who dissolve a colour or a flavour in water cause the water to absorb it, so nature acts upon the dry and earthy elements, and by filtering water through these elements, and stimulating them into activity by heat, it causes the moist element to acquire a certain quality. This condition, which is wrought in moisture by means of the above-mentioned dry element, is flavour, and it consists in the conversion of a potential taste into an actual one. For the sense organ, which is already in a condition of potentiality, passes over into a condition of actuality. The process of sensation does not resemble learning so much as it resembles contemplation. That flavours do not attach to everything dry, but only to the dry that is nutritive, either as a positive or negative condition, one may conclude from the fact that the dry is not found apart from the moist, nor the moist apart from the dry. Neither one when taken alone is foodstuff for living creatures, but only when combined. In animal food it is the tactual elements which effect growth and decay, and it is by virtue of the warmth or cold in the assimilated food that these phenomena are produced. For these are the properties that cause growth and decay. The administered food nourishes in so far as it is gustable, for everything is nourished by means of the sweet, whether pure or mixed. This subject must be more definitely treated in the work On Generation. For the present we only touch upon it so far as necessary. Heat disposes to growth and brings food into a prepared condition. It absorbs what is light and rejects the salt and bitter because of their heaviness. What external heat effects in external bodies is also produced by internal heat in animals and plants. Nourishment, then, is caused by the sweet. The other flavours are mingled in food in the same way as the bitter and pungent, i.e. to serve as a relish. This is for the purpose of counterbalance, and because the sweet is over-nutritive and swims on the stomach. As colours are a combination of white and black, so flavours are derived from sweet and bitter. They depend severally on a proportion of more or less, on a proportion of mixture and motion, either numerically expressible or indeterminate. Those mixtures, however, which produce pleasure are numerically expressible. The oily flavour is to be classed with the sweet. The salt and bitter are closely allied, while the sour, pungent, astringent, and acid are intermediary. And so the varieties of flavours and colours are pretty nearly the same in number, for there are 6 of each, if one regards, as is reasonable, the grey as a sort of black. We have then to include yellow in white, just as we referred the oily flavour to the sweet, while crimson, sea purple, green, and blue are intermediary between white and black, and all other shades are combinations of these. As black is privation of the white in a diaphanous medium, so the salt and bitter are privation of the sweet in a nutritive moist substance. Consequently, the ashes of anything that has been burnt are bitter, for the potable element has been consumed. Democritus and most of the physiologers who treat the subject of sensation make the most remarkable blunder, for they resolve all sensible objects into the tangible. If indeed this is correct, each of the senses becomes evidently a sense of touch. It is not difficult to see that this is impossible. Further, they treat the common functions of all the senses as special functions. For the perception of magnitude, figure, roughness, smoothness, and sharpness and bluntness in solid bodies is the common function of all the senses, and if not of all, then at least the common function of sight and touch. It is in these perceptions, therefore, that the senses are subject to error, but they are not subject to error in their special sensations, e.g. sight is not fallible regarding colour, nor hearing regarding sound. Again, these physiologers refer the special functions to the general, as Democritus does with white and black, the latter of which he identifies with the rough, and the former with the smooth. And he reduces flavour to atomic forms. And yet it is either not the function of any sense to discern common properties, or else this power belongs to the eye more than to any other organ. If, however, this power falls rather to the lot of taste, it is at any rate the function of the most delicate sense to discriminate the slightest distinctions, each after its kind, so that taste would have to discriminate common properties better than any other sense, and be the most discerning judge of atomic figures. Further, all sensible objects contain the principle of opposition, e.g. in colour, black is the opposite of white, and in flavour, bitter is the opposite of sweet. But one figure does not appear to be the opposite of another figure, for to what sort of polygon would a circle be opposed? Further, the atomic figures being infinite in number, it necessarily follows that flavours are also infinite in number. For what is the explanation of the fact that one flavour produces a sensation and another flavour does not produce it? We have now treated the subject of the gustable and flavour. The other aspects of flavour receive their proper consideration in the treatise On the Physiology of Plants. End of chapter 4. Recording in memory of Mitchell Edwards. Chapter 5 of On Sensation and the Sensible in Parva Naturalia by Aristotle. Translated by William Alexander Hammond. This LibriVox recording is in the public domain. Recording by Geoffrey Edwards. Chapter 5. In like manner, one must also treat of smell. For the same effect which is produced by the dry or the moist is produced in another connexion by savoury moisture in air and water equally. Now, we observe that the diaphanous is a common principle in these two elements. The element, however, is not odoriferous by virtue of its being diaphanous, but by virtue of its capacity to exude and throw off dry savour. For smell is exercised not only in the air, but also in water. This is evidently so in the case of fishes and molluscs. For these are known to be endowed with smell, although there is no air in the water. For the air comes to the surface when found in water, and they have no respiration. If one assumes that both air and water are moist elements, smell would be the dry sapidity in the moist, and such would be the nature of an odoriferous body. That this condition in an object is derived from a sapid element is a plain conclusion from things that do and do not emit smell. For the simple elements such as fire, air, earth, and water are non-odorous, because the moist and dry in them are non-sapid, excepting when a combination is produced. This is why even the sea has a smell. It contains a sapid dry element. Salts are more odorous than nitre, as is proven by the oil derived from them. Nitre, in turn, is more odorous than earth. Further, a stone is inodorous, for it is without sapidity. Woods, on the other hand, are odorous, for they are sapid, and, amongst woods, those that are watery are less odorous. Further, amongst metals, gold is inodorous, for it is not sapid. Bronze, however, and iron are odorous. When the moist element is burned out of metals, the slag becomes still less odorous. Silver and tin are more odorous than some and less odorous than other metals, for they contain moisture. Some writers regard smell as a smoke-like exhalation, which is common to earth and air, and all the naturalists fall back on this explanation of smell. And so Heraclitus made the remark that if all things were smoke, we should discern everything by our nostrils. Now, the naturalists all explain smell on this theory, some of them describing it as vapour, others as an exhalation, and others as a combination of both of these. Vapour is a kind of moisture, whereas a smoke-like exhalation is, as we have said, common to air and earth. Water is derived from vapour, and a sort of earth is developed from smoke-like exhalation, but neither of these two seems to be the odorous, for vapour is due to water, while smoke-like exhalation cannot possibly be generated in water, and yet creatures that live in the water have the sense of smell, as was said above. Again, exhalations here have the same meaning as emanations, and if the emanation theory was wrong, so is this wrong. It is clear that the moisture which is found in the air, for the air also has a moist character, and in water is capable of deriving something from the sapid dry element, and of being affected by it. Furthermore, if the dry element, when saturated, as it were, acts in moisture in the same way as it does in air, smells must evidently correspond to tastes. But precisely this fact is found in certain flavours and savours, for there are pungent, sweet, harsh, astringent, oily smells, and one might say that rancid odours correspond to bitter tastes. As the former, therefore, are revolting to the taste, so rancid tastes are revolting to the smell. Evidently, then, that quality which in water is flavour, in air and water is smell. This explains why cold and frost blunt flavours and obscure smells, for cold and frost nullify heat, which is the moving and active principle here. There are two sorts of odorous objects, for it is untrue that there are no varieties of odorous objects, as some maintain. Such varieties do exist. One must, however, explain in what sense this is true, and in what sense not true. One variety corresponds, as clearly explained, to flavour, and contains the pleasurable and painful accidentally. For, owing to the fact that these smells concern our nutritive power, they are agreeable to those who have desire, and disagreeable to those who are sated and feel no desire. Neither is the smell agreeable to those to whom the food which has the smell is disagreeable. Consequently, these smells contain, as we said, the pleasant and painful accidentally, and this is the reason why they are common to all animals. There is another variety of smells which are pleasant in themselves, e.g., the fragrance of flowers, for they incite us in no respect, whether more or less, to food, nor do they in any way contribute to the stirring of any desire. They have rather the opposite effect. What Stratus says, mocking Euripides, is true. When lentil soup you cook, pray add no spices to it. By mixing such spices in their potations, men nowadays force pleasure, as is their habit, believing that the pleasure which is really derived from two sensations is derived from only one. Smell of this sort is peculiar to man, but smell that is based on flavour is sensed by other animals, as remarked above. The varieties of the latter, because the pleasant is incidental, are classified in terms of flavours, which does not apply to the former class, because there the smell is pleasant or disagreeable in itself. The reason why this class of smells is peculiar to man is because of the condition of his brain. For man's brain is by nature cool, and the blood in its surrounding veins is thin and pure, though easily chilled, which explains why the evaporation of food, when cooled in this region, causes catarrhal colds. And so this variety of smell has been developed in man as beneficial to his health. For no other function can be ascribed to this class of smells, although this function is evidently exercised by them. Food, whether solid or liquid, although agreeable, is often harmful, but the smell exhaled from savoury food indicates, one may say, what is absolutely and always beneficial to man in whatsoever condition he is. Consequently, smell is mediated by respiration, not in all animals, but in man, the quadrupeds, and such other sanguineous animals as have a larger share in the employment of air. For smells being transmitted to the brain by virtue of the levity of the heat in them, the regions about the brain are thereby the more healthy. For the potency of smell is naturally warm. Nature employs respiration for two purposes. Its main purpose is to assist the functioning of the chest. Its secondary function is to transmit smell. For in respiration the air produces, as it were in passage, motion in the nostrils. Smell of this sort is peculiar to human nature, for man has, in proportion to his size, the largest and moistest brain of all animals. For this reason man is the only animal, one may say, that senses the smell of flowers and similar smells, and finds pleasure in them. For the warmth and movement in these smells is proportional to the excess of moisture and coolness in the brain. To the other animals that are endowed with lungs for respiration, nature has given the perception of another kind of smell, so as to avoid the creation of two sense organs. It is enough for these respiring animals that they have the sensation of only one class of smells, while man discriminates both classes. That the non-respiring animals possess the sense of smell is evident. For fishes and all the varieties of insects, on account of the connection between food and smell, distinguish smells with precision and at a distance, as we observe in the case of bees and that variety of small ants, sometimes called snips, and purple sea fish, as well as in the case of many other similar animals which have a keen sense of smell for food. The organ of sensation is not so clearly defined. One might therefore raise the question as to the organ of the sense of smell, although smell is mediated exclusively by respiration. This is plainly so in all respiring animals. None of the above-mentioned animals, however, respire, and yet they perceive smells, unless we are to assume an additional sense beyond the five, and this is impossible. For it is smell that senses the odorous, and these animals detect odour, though perhaps not in the same way as respiring animals. In respiring animals, the breath lifts up a superficial membrane, a sort of cover as it were, for which reason they do not smell without respiration, whereas in the non-respiring animals this is lacking, just as over the eyes some animals have eyelids, and without lifting these do not see, while others are hard-eyed, and have no lids, and so do not need to lift any covering, but see at once from the moment they are able to see. And so too no other animal feels discomfort from a smell which is intrinsically malodorous unless it chances to be harmful. But by these harmful smells animals are sometimes destroyed, just as men often get a headache from coal gas, and frequently lose their lives. In the same way other animals are destroyed by sulphur and asphalt fumes, and because they are so affected by such fumes they avoid them. But for malodour as such they take no thought, although many vegetables have bad smells, excepting in so far as taste or food is influenced by it. Inasmuch as the number of the senses is uneven, and every uneven number has a middle term, it seems that smell occupies a middle position between the senses that operate by direct contact, viz. Touch and taste, on the one hand, and those which function indirectly through a medium, viz. Sight and hearing, on the other hand. Consequently, the odorous object is something which affects foods, for these fall under the category of the tangible, and further it affects audition, because smells are sensed in the media of air and water. Smell, then, is in a way common to these two things, and is found in the tangible, the audible, and the diaphanous. It is with good reason, therefore, that smell has been compared to the imbruing and washing of a dry element found in the moist and liquid. Regarding the sense in which one may or may not apply the term 'species' to odours, let the foregoing discussion suffice. There is a view held by certain Pythagoreans which is ill-founded. They hold that certain animals feed on smells. Now, we observe in the first place that food is a composite thing, for the creatures which are nourished are not simple, and consequently there is an excrement of food, sometimes within the animal itself, and sometimes external, as in the case of plants. Further, water, when taken alone and unmixed, is not fitted to yield nourishment, for what is assimilated into the body must be of a solid nature. Again, it is much less reasonable that air can become solid matter. In addition to this, we observe that all animals have a receptacle for food, from which, after its entrance, the body assimilates it. The sense organ, however, is situated in the head, and smell enters with a breath-like inhalation, so that it penetrates to the respiratory region. That smell, as such, does not contribute to nourishment is plain. That it does, however, contribute to health is evident from the sensation itself and from what has been said, so that what flavour is to the nutritive organ and to the parts nourished, this smell is to health. Let these, then, be our conclusions regarding the several sense organs. Chapter 6. One might raise the question whether, supposing all bodies to be infinitely divisible, the sensible qualities of bodies are also infinitely divisible, such qualities as colour, flavour, smell, sound, weight, cold, heat, lightness, roughness, and softness, or must we say that this is impossible? For every one of these qualities produces sensation. They all receive their name from their capacity to stimulate sensation. Therefore, sensation must be infinitely divisible, and every magnitude must be sensible, for it is impossible to perceive a white object without its having dimensions. Were this not true, it would be possible to have a body without colour or weight or any similar quality, in which case it would be absolutely imperceptible, for these qualities constitute the sensible. The sensible, then, would have to be composed of the non-sensible, but it must be composed of sensible qualities, for it cannot be composed of mathematical elements. And furthermore, what organ could we use for the discrimination and cognition of such elements? Could we employ reason? But they are not rational elements. Neither does reason think the external world, excepting in conjunction with sensation. At the same time, if this view of the infinite divisibility of sensible qualities were true, it would appear to furnish support for the advocates of atomic magnitudes, for in this way the problem would be solved. It is, however, impossible. This subject has been discussed in our treatise On Motion. In the solution of these questions, one will see why it is that the various forms of colour, flavour, sound, and other sensible qualities are determinate. For in things that have extremes, the internal properties must also be determinate. The opposite is an extreme. Now, every sensible quality implies opposition, e.g. in colours, white and black, in flavour, sweet and bitter, and in everything else the opposites form extremes. The continuous is therefore divisible into infinite unequal parts, but into determinate equal parts. Now, whatever is not in its own nature continuous is divisible into determinate forms, inasmuch as qualities must be interpreted as forms, and inasmuch as continuity is always given in these, We must suppose a difference between the potential and actual. This is why the 10,000th part of a visible grain of millet is unseen, although the eye rests upon it, and so too a quarter tone is undetected by hearing, although the whole continuous melody is heard. But the interval from mean to extreme is not appreciable to us. And the same thing applies to the excessively small amongst other sensible objects. They are discernible potentially, but not actually, and when regarded in isolation. A foot line is contained in a 2-foot line potentially, but actually only after division has been made. When excessively small parts like these are separated off, it is reasonable to suppose that they would be lost in their environment, just as a tiny particle of flavour is lost in the sea. Nevertheless, since this excessively small particle, when regarded in itself and in isolation, is imperceptible, for the excessively small has only a potential existence in a body that is more discernible, neither is any sensible object of this sort, in isolation, actually perceptible, and yet it is a sensible object because it is so potentially, and will be actually so when added on to something. We have now explained that certain magnitudes and qualities are imperceptible, and have stated the reason for this, and have shown in what sense things are perceptible, and in what sense they are not. When, however, inherent qualities are so constituted in reference to themselves as to be actually perceptible, and not merely so in conjunction with an entire body, but also when regarded alone, then colours, flavours, and sounds must be numerically limited. One might raise the question whether sensible objects, or the movements excited by sensible objects, whatever be the way in which sensation is affected by their activity, are first transmitted to a medium, as appears to be the case with smell and sound. For a person standing nearby has an earlier perception of a smell, and a sound reaches one some time after a blow. Is the same thing true of the visible and of light? According to Empedocles, sunlight is first transmitted to a medium before it reaches the eye or the earth, and this seems to be reasonable. For whatever is moved from one point to another, so that a certain time must elapse in which motion from one point to another takes place. But all time is divisible, and consequently there is a moment when the ray is not yet visible, but is still in transit in the medium. Also, if everything at the same moment hears and has heard, and in a word perceives and has perceived, and there is no time process in sensations, nevertheless they lack this process in the same way in which sound, after the blow has been struck, has not yet reached the ear. The shifting of letters also shows this plainly, because their movement takes place in a medium. For people appear not to have heard what was said because the air has shifted. Is this true also of colour and light? For it is not owing to a particular condition that one thing sees and another is seen, like two equivalent terms. For it would not then have been necessary for either to be in a given position. For when things are equivalent, nearness or remoteness from each other makes no difference. It is reasonable that succession in time should be found in sound and smell. For, like air and water, they are continuous, and yet their movement is divisible. And so it sometimes happens that the nearest and most remote persons perceive the same smell, and at other times this is not the case. Some persons find a difficulty also in the following. It is impossible, some say, for different persons to hear, see, or smell the same thing in the same way. For it is impossible for several persons who are separate from each other to hear and smell alike. In that event, the unitary object of sensation would have to be separated from itself. The primary stimulus, as a bell, frankincense, or a fire, is perceived by all as numerically one and the same, but in its peculiar qualities it is perceived with numerical differences, though in its essential nature as one and the same thing, for which reason many persons see, smell, or hear the same thing at the same time. One is not concerned here, however, with bodies, but with qualities and motion, otherwise we should not have this phenomenon, which are impossible apart from body. The question of light is different, for light has a substantial nature and is not a motion. In general, the same determinations are not to be applied to transformation and motion. Spatial motions take place, as one might suppose, first into a medium. Sound is thought to be the motion of something subject to spatial change, whereas that which undergoes transformation does so in a way different from spatial change. It is possible that transformation takes place in mass, and not first by halves, as in the case of water which freezes at once entire. Nevertheless, if what is being heated or frozen should be of considerable bulk, one part is affected by the adjacent part, and the first part undergoes changes through its own alteration, and it is not necessary that the entire mass undergo alteration at the same time. Taste would also be subject to the same conditions as smell, if we lived in a medium of water and perceived smells from a distance without contact. When we have a medium for the sense organ, it is reasonable to suppose we do not receive all our impressions at once, excepting in the instance of light, on grounds already mentioned. And sight is also accepted on the same grounds, for light is the cause of sight. End of chapter 6. Recording in memory of Mitchell Edwards. Chapter 7 of On Sensation and the Sensible in Parva Naturalia by Aristotle. Translated by William Alexander Hammond. This LibriVox recording is in the public domain. Recording by Geoffrey Edwards. Chapter 7. Another similar problem touching sensation arises here, viz., whether or not it is possible to experience two sensations at one and the same moment of time, supposing it to be true that the stronger stimulus always displaces the weaker. For this reason, persons do not see an object that falls upon the eye if they chance to be deep in thought, or exercised by fear, or listening to a loud sound. Let this serve as a fundamental truth, and let us also observe that it is easier to perceive what is simple than what is mixed, e.g., it is easier to taste unmixed wine than mixed, and so with honey and colour, and it is easier to distinguish the highest note when taken alone than when heard in accord with the octave, because the two things obscure each other. This occurs in cases where a unity is produced from several elements. If, then, the stronger displaces the weaker stimulus, it must happen, in case they are simultaneous, that even the stronger stimulus becomes weaker than it would be if it were perceived alone. For the weaker, when mixed with it, detracts from its clearness, supposing it to be true that everything taken simply is more accurately perceptible. If the two are equal, neither one will be perceived, for they will counteract each other equally. But it is impossible to have a simple sensation. Consequently, we shall have either no sensation at all, or a new one fused out of both elements. And this appears to be what actually happens with mixed elements, so long as they are mixed. Since a fusion of certain things is possible, and of others not, the latter are such as fall within the province of different senses. For where extremes are opposite, fusion is possible, but it is not possible to form white and acute into a unity, excepting in an accidental sense, not, however, in the sense in which a union between acute and grave is possible. It is then impossible to have a simultaneous sensation of these qualities, for the stimuli being equal destroy each other, since a unitary stimulus is not derivable from them. If, however, they are unequal, the stronger stimulus produces the sensation, for the soul more readily perceives two stimuli simultaneously when only one sense is concerned in the single act of sensation, as e.g. acute and grave. For simultaneous sensation on the part of a single sense is more easily attained than is the action of two senses, such as sight and hearing. But it is not possible to perceive two things simultaneously with one sense unless they are fused, for the fusion will form a unity, and a single sense can perceive a single thing, and the single sensation is a chronological unit. So then, one necessarily perceives fused stimuli simultaneously, because they are perceived by a sense process which in actuality is single. The single sense in actuality perceives a numerically single object. The single sense in potentiality perceives a specifically single object. If the sensation, therefore, is in actuality single, it will interpret the sense object as a single thing. The sensations must then be fused. When they are not fused, the sensations will be in actuality too. However, there must be a single actuality which corresponds to a single potentiality and a single moment of time. For the stimulation and exercise of a single sense is once for all single, and its potentiality is single. It is consequently impossible to perceive two objects at one time with a single sense. But if two objects that fall under a single sense cannot be perceived simultaneously, this is plainly much less possible when they fall under two senses, as e.g. white and sweet. For the soul seems to denote what is numerically one, not otherwise than in terms of simultaneity, the specifically one in terms of the discriminating sense and the character of the thing. By this I mean that white and black, which are specifically different, are supposedly discriminated by the same sense. Also, sweet and bitter are discriminated by the same sense, although a different sense from the former one. On the other hand, the method of perceiving opposites is different. While coordinated pairs are perceived in the selfsame manner, e.g., just as taste perceives the sweet, so sight perceives the white. As the sense of sight perceives the black, so the former sense perceives bitter. Further, if the sense processes of opposites are opposite to each other, and if it is impossible for opposites to coexist in the same indivisible thing, then where opposites fall under a single sense, as e.g. sweet and bitter, they cannot be perceived simultaneously. And similarly, it can be proven that things which are not opposites cannot be simultaneously perceived. For some colours partake of white and others of black, and this applies equally to other sensations, e.g. amongst flavours, certain ones have the character of sweet and others of bitter. Neither can fused objects be simultaneously perceived, for their ratios have the character of contrariety, e.g. the octave and the fifth, unless they are perceived as one. In this way, and not otherwise, a single ratio of extremes is produced. For in any other case there will be produced at once the ratio of the many to the few, and of the uneven to the even, and on the other hand the ratio of the few to the many, and of the even to the uneven. If coordinates, which are specifically different, are further removed from each other, and differ more than things that are specifically the same, e.g. sweet and white I mention as coordinates, but specifically different, and sweet differs from black more than white does, it would be still less possible for these opposites to be perceived simultaneously than it would be for opposites specifically the same, so that if the latter are not simultaneously perceptible, neither would the former be. In regard to the opinion of certain writers who treat the subject of harmony and say that sounds do not really reach us at the same moment, but only appear to do so, and we do not notice this, the time being imperceptible, the question is whether their opinion is right or not. Here also one might perhaps say that we only appear to hear and see at the same time, because the intervening time is not perceived. This is incorrect. It is impossible for time to be imperceptible, or for us to be unconscious of it, but every moment is perceptible. For when one perceives oneself or something else in continuous time, it is impossible for one to be then unconscious that one is. But if there is in continuous time a moment of such duration that it is altogether imperceptible, it is evident that one would then be unconscious of one's own existence, or would not know whether or not one sees and perceives. Further, even if one has perception, time would not exist, and there would be no object, nor any moment in which sensation should take place, unless it were in the sense that one sees in a part of time, or a part of the object, if there is a measure of time or object which, owing to its smallness, is totally imperceptible. For if one sees the entire earth, one also perceives time itself in its continuity, and not in any of its isolated moments. Let C, B represent a time division in which one has no perception. One sees then in a particular part of the whole, or sees a particular part, just as one sees the entire earth, viz. By seeing a definite part of it, and how far one walks in a year, viz. By seeing how far one walks in a definite part of a year. But in the division B, C, there is no perception. Now, by virtue of perceiving the whole, A, B, in some definite part of it, one is said to perceive even the entire earth, and the same reasoning holds good of A, C. For one always perceives in a part, and it is impossible to perceive the entirety, and so everything is perceptible, but one does not see what its extent is. For one sees the magnitude of the sun, and of the 4-cubit measure from a distance. They are not seen, however, in their real size, but sometimes they seem indivisible, and one does not see the indivisible. The reason for this has been stated in the foregoing. One concludes from this that there is no imperceptible time. We must take into consideration the above-mentioned problem, whether or not it is possible to have several simultaneous sensations. By 'simultaneous' I mean such as are experienced in the same part of the soul, and in one indivisible moment of time. In the first place, then, is it possible that the sensations be simultaneous in the sense that they are experienced in different parts of the soul, and not in one indivisible part, though by parts which are indivisible in the sense of forming a continuous whole? Or, to take first what affects the single sense, as e.g. sight, shall we say that if different colours are sensed by different parts of sight, it will then have several parts specifically the same? For its repeated sensations belong to the same species. But if one says that, as in the instance of our two eyes, a certain unity and single activity is produced, so nothing prevents our regarding the soul in the same way. If, however, the combination of both forms an unit, then that which is perceived will be an unit, and if they remain uncombined, then the result will likewise be uncombined. Again, the same sensations will be manifold in the sense in which one speaks of sciences as manifold, for neither is there any actuality apart from its corresponding potentiality, nor is there any sensation apart from actuality. If one does not experience simultaneously the sensations which occur in a single indivisible part of the soul, it is clear that one does not experience others simultaneously. For it is simpler to perceive these several things simultaneously than it is to perceive generically different things simultaneously. But if the soul senses sweet with one part and white with another part, the derivative of these two is either an unit or it is not an unit. But it must be an unit, for the perceiving organ is an unit. What is the unit, then, with which this organ is concerned? For we have no unit from sweet and white. There must, therefore, be some unitary principle in the soul whereby it perceives things as wholes, as remarked above, but things generically different are sensed by different organs. Is then the principle whereby we perceive sweet and white a single organ, in so far as these qualities are united? But when they are actually isolated, is it a different organ that senses each of them? What applies to the things themselves applies similarly to the soul. For numerically one and the same thing is white and sweet, and possesses many other qualities, unless the qualities be regarded as isolated from one another, and yet the essential nature of each quality is different. One must likewise conclude, in reference to the soul, that one and the same principle, numerically regarded, perceives everything, although its mode of expression is different, in some cases generically different, and in others specifically different. Simultaneous sensations, therefore, are experienced in one and the same principle of the soul, but not in one and the same relation to this principle. It is evident that every sensible object has a certain magnitude, and that it is impossible to perceive what is indivisible. There is a point from which it is impossible for one to see, viz., a point of infinite removal, but the point from which vision is possible is determinate. The same applies to the odorous and audible, and to such sensations as are not tactual. There is an extreme point of remoteness from which vision is no longer possible, and a point of nearness at which vision begins. This point must be indivisible, and what is beyond it is not perceptible, and what is on this side of it must be perceptible. If, indeed, an indivisible thing is perceptible, then it will follow, when one places it at the extreme point from which it is no longer visible, and again at the point where perception begins, that it is simultaneously visible and invisible, and this is impossible. We have now treated in general and in particular the subject of the organs and objects of sensation. In what remains, we must first investigate the subject of memory and of memory's process. End of chapter 7 and end of On Sensation and the Sensible. Recording in memory of Mitchell Edwards. Chapter 1 of On Memory and Recollection in Parva Naturalia by Aristotle, translated by William Alexander Hammond. This LibriVox recording is in the public domain. Recording by Geoffrey Edwards. Chapter 1. In regard to memory and its process, we must determine what its nature is, by what agency it is produced, and to what physical organ the phenomenon of memory, as well as that of recollection, is to be ascribed. For the same persons are not endowed with good memory and good recollection, but, as a rule, phlegmatic natures remember well, while the quick and ready-witted are apt at recollection. First of all, we must grasp what is understood by the object of memory, for one is often mistaken about this. The future cannot be the object of memory. This is rather the object of conjecture and expectation, and we might even have a science of expectation, as some describe the subject of prophecy. Neither can the present be its subject matter, for our senses are concerned with this. By sensation we do not have cognizance either of the future or of the past, but only of the present. Memory, on the other hand, regards the past. No person would say that he remembers the present while it is present, e.g., that he remembers seeing the white object while he sees it. Neither does one remember the object of contemplation, so long as the act of contemplation and thought continues. But one merely says that in the former case one sees, and in the latter one knows. When, however, one possesses knowledge or sensation which is not in actuality, then one remembers that the angles of a triangle are equal to 2 right angles, because one has learned it, or thought it out, or, on the other hand, has merely heard it, or visually observed it, or found it out in some such way. For when memory actually takes place, one must say that the process in the soul is such that one formerly heard, perceived, or thought the thing. Consequently, memory is neither sensation nor conceptual thought, but it is the condition or modified form of one of these after the lapse of time. There is no memory of the present in the present moment, as we have said. But there is perception of the present, expectation of the future, and memory of the past. Consequently, all memory is associated with time. Therefore, only those creatures that have perception of time have memory, and memory attaches to that organ whereby time is perceived. Now, we have already discussed imagination in the treatise On the Soul, and we concluded there that thought is impossible without an image, for we find in thought the same conditions as in drawing figures. In the latter, without needing a triangle of a definite magnitude, we nevertheless draw a triangle of definite size. So too, the thinking mind, even if it does not think a magnitude, still places a quantitative body before its eyes, although it does not think it as such. If it is the nature of the quantitative in an indefinite sense with which the mind is concerned, then thought represents it under the form of a definite quantity, but thinks it merely as quantity. The reason why it is impossible to think anything apart from continuity (even things that are not subject to the laws of time cannot be thought without time) is a problem that belongs elsewhere. We must be conscious of magnitude and motion by the same faculty whereby we are conscious of time. An image is a product of sensation in general. Evidently, therefore, the cognition of these things is to be ascribed to the primary power of sense. Memory, even the memory of concepts, does not take place without an image. Consequently, memory concerns the faculty of thought accidentally, and the primary power of sense intrinsically. It is therefore possessed by other animals, and is not peculiar to man and creatures endowed with opinion and thought. If it were a property belonging to the conceptual powers, it would not be found in many animals outside of man, perhaps in none of the brutes, seeing that they do not, as a matter of fact, possess it, because they all lack the sense of time. For in an activity of memory, as we remarked before, there is always the additional consciousness that one has seen or heard or learned this in time past. Prior and later are properties of time. In reply to the question to what part of the soul memory is to be ascribed, it is plain that it belongs to the same part as imagination. The objects of memory, intrinsically, are the same as the objects of imagination. Accidentally, they are such objects as are impossible without imagination. The question might be asked, how in the world is it that, while a mental impression persists, although the thing itself is no longer at hand, one remembers what is not present? Evidently, we must regard this phenomenon, which through the mediation of sensation is produced in the soul, and in that part of the body which possesses sensation, whose persistence we call memory, as similar to a painting. For an active stimulus stamps on the soul a sort of imprint of the sensation, analogous to stamping with a seal ring. For this reason, too, persons who are deeply moved by passion or by the ardour of youth do not remember, just as if the effort and the seal were applied to running water. In other persons, because of their worn-out condition, like old buildings, or because of the hardness of their receptive principle, no impression is made. Consequently, the very young and the aged have poor memories, for the former are in a fluent condition owing to their growth, and the latter are unstable owing to their decay. Likewise, the excessively quick and the excessively slow seem to have poor memories. The former are too moist, and the latter too hard. Consequently, the image does not last in the souls of the former, and in the latter it does not fasten. If such is the truth regarding memory, the question arises whether one remembers the impression or the thing from which the impression was derived. For if it is this impression of ours which is the object of memory, then we do not remember what is absent. On the other hand, if it is the thing that we remember, how does it come that while we perceive this impression, we remember what we do not perceive, viz., the absent thing? And if memory is analogous to an imprint or picture within us, why should the perception of precisely this thing be the memory of something else, and not the memory of just this picture? For it is this impression which one contemplates and perceives in actual memory. In what sense, then, does one remember what is not present? It would then be possible to see and to hear what is not present. Or is there a sense in which this is possible and in which it actually occurs? For example, the animal in a picture is both animal and a copy, and both of these are one and the same thing. But the mode of existence in the two instances is different, and it is possible to regard this picture both in the sense of animal and in the sense of image, and so it is with the image within us. We must regard it both as something in itself and as the image of something else. Insofar as we regard it in its own nature, it is an idea or a mental representation. Insofar as we regard it as belonging to something else, it is a copy or a memory. When, therefore, an actual stimulation of this image takes place, and when the soul perceives it in its own nature, it appears to come to expression as an idea or a phantasm. If, however, the soul regards it as belonging to something else, then, as in the case of a painting, the soul contemplates it as a copy, and as the picture of Coriscus, without having ever seen him. The points of view here, and in the case of our regarding a painted animal merely as an animal, are different. What arises in the soul in the latter case is purely a thought. In the former case, because the object is there regarded as an image, it appears as a memory. And, consequently, there are times when we do not know, regarding such physical processes due to earlier sensations, whether they are produced by sense experience, and we are in doubt whether they are a memory or not. At another time, it happens, we think and recall that we have heard or known the thing in the past. This takes place when, after contemplating a thing in its own nature, one shifts one's position and regards it as the copy of another thing. The converse of this also happens, as is shown by the case of Antiphoron of Oreos and other ecstatics, for they asserted that their phantasms were real, and that they remembered the things. This phenomenon occurs when one regards as a copy that which is not a copy. Exercise in repeatedly recalling a thing strengthens the memory. This, however, is nothing more nor less than the frequent contemplation of a thing as a copy, and not as an object in itself. The nature of memory and of its process has now been explained as the persistent possession of an image, in the sense of a copy of the thing to which the image refers, and it has been further explained to what faculty in us this belongs, viz., to the primary power of sensation, and to that organ whereby we perceive time. Chapter 2. The subject of recollection remains to be treated. First of all, we must take as presuppositions the truths which were established in the treatise on argumentation. Accordingly, recollection is neither the recovery nor acquirement of a memory. For when one learns or acquires an impression for the first time, one does not recover any memory, for none has preceded, nor does one acquire an initial memory. But when a persistent mental condition and impression is fixed in the soul, then we have memory. Consequently, memory is not produced simultaneously with the production of an impression. Further, in the indivisible complete moment, when the impression is first received, the impression and the knowledge are recorded in the affected subject, if one can call this mental condition and impression knowledge, and there is nothing to prevent our remembering, in the sense of accident, a certain thing which we know conceptually. But memory as such is not possible until after the lapse of time, for what we remember now we have previously known or experienced, but what we experience now is not in the present moment remembered. Further, it is evidently possible to have in memory what we do not now recollect, but what was once perceived or experienced. When one reacquires knowledge or sensation, or whatever the mental possession be to which we apply the term memory, it is then that one recollects one of the aforesaid mental possessions. The process of memory takes place, and memory ensues. Neither do the phenomena of recollection, if their occurrence is the repetition of a previous recollection, follow absolutely the same order, but sometimes they occur in one way, and sometimes in another. It is possible for the same individual to learn and discover the same thing twice. Recollection, then, must differ from learning and discovery, and there is need of greater initial latitude here than is the case with learning. Recollection is effected when one suggestion succeeds another in natural order. If the succession is a necessary one, it is plain that when the antecedent suggestion is given, it will excite the succeeding one. If, however, the succession is not a necessary one, but only customary, the recollection will be stirred generally. But it is a fact that some persons, by being impressed only once, are trained in a given way more than others after frequent impressions. And so there are some things which, after we have seen once, we remember better than others do who have seen them frequently. When, therefore, we recollect, we awaken certain antecedent processes, and continue this until we call up that particular experience, after which the desired one is wont to appear. That is the reason why we hunt through a series in thought, beginning with an object presently before us, or with something else, or with an object that is similar, or opposite, or contiguous. In this way, recollection is awakened. For mental movements in these instances are identical in some cases, in others simultaneous with the desired experience, and in other cases they involve a portion of it, so that there is a small remainder whose stimulation ensues. This, then, is the way in which people try to recollect, and without conscious effort they recollect in this way, when the desired experience is recalled as the sequence of another experience. For the most part, however, the desired experience is recalled only after several different suggestions, such as we have described, have preceded. One does not at all need to look at the remote and ask how we remember it, but at what lies near before us. For the same method applies to both cases, I mean the method of sequences, without any prior effort to find this sequence, and without recalling it. For mental movements follow one another, this one after that, by habituation. When a person wants to recall a thing, he will do the following. He will try to gain a starting point in the process, in sequence to which the desired experience was had. Consequently, recollections which are awakened from the starting point are most quickly and best effected. For just as things are mutually related in their order of succession, so also are the mental processes. And such things as have a fixed order are easily remembered, as, e.g., mathematical truths. Other things are remembered poorly and with difficulty. Recollection differs from relearning in this, that there can be in the former case a sort of self-movement back to that which follows upon the original experience. When this is not done, but the recollection is prompted by another person, then it is no longer memory. Oftentimes one is unable to recollect a thing, but after searching succeeds in finding it. This seeking and finding is what happens when one awakens a number of experiences, and continues to do so until one sets that particular experience in motion upon which the desired thing is attendant. Memory is the possession of an experience potentially revivable. This process is effected, as was said above, in such way that it comes from the person's own effort, and from the movements in his power. One must, however, have a starting point, and so persons appear sometimes to recall things from local suggestions. The reason is that one passes rapidly from one thing to another, e.g. from milk to the suggested idea of white, from white to air, from air to the moist, and from this one recalls the late autumn, which is the season one was trying to think of. In general, it is the middle two of the entire series that seems to be the starting point for memory. For when a person does not remember earlier, then he does so when he comes to the middle point, or when he does not remember here, then at no other point at all, as is the case, e.g. when one passes through the series a, b, c, d, e, f, g, h. If one does not remember at h, one remembers when one comes to e, provided one is in quest of f or g. For from that point the movement of suggestion is possible in both directions, towards the point D as well as towards the point F. If, however, a person is not in quest of one of these, he will remember on reaching C, and if not then, he will remember on reaching A, and this is the case always. But from the same point of suggestion one sometimes remembers and sometimes does not, the reason for which lies in the possibility of movement in more than one direction from the initial point, e.g. from E to F, or from E to D. If the movement is influenced by an old suggestion, it takes place in the direction of the more fixed habit. For habit is second nature. Consequently, we remember easily what we often ponder. For as one definite thing succeeds another in nature, so it is also in our activity. Frequent repetition produces nature. Since we find in the realm of nature occurrences that violate her laws and are due to chance, much more do we find this in the realm of custom, to which the term nature cannot be applied in the same sense. The consequence is that a movement here sometimes takes place in one direction, and sometimes in another, especially when the mind is distracted from a particular point to something else. Therefore, when one has to remember a name, and remembers one like it, one commits a solecism in regard to it. This, then, is the way in which recollection takes place. The most important thing here is the necessity of appreciating time, whether in a determinate or an indeterminate form. There must be some power whereby we distinguish a longer from a shorter interval. It is natural that the same conditions which apply to magnitudes apply here also. For we think what is large and what is remote in space, not because thought extends to the given point, as some say in their explanation of vision, for we can think the non-existent as well as the existent, but because of an analogous process in the mind. For the figures and processes that correspond to things are in the mind itself. What difference will it make, then, whether one thinks what is larger, or the other class of things that are smaller? For all the internal elements are smaller, and the external have, as it were, a proportional magnitude to them. It is perhaps in the case of distances in space, just as it is with figures, one has to assume the possession of another analogous figure in the mind itself. So, e.g., if one draws the lines EB and BE, one produces CD. For AC and CD are proportional. Why does this produce the line CD rather than FG? Or is this due to the fact that as AF is to AB, so H is to M? For these lines are drawn at the same time. And if one wants to think the line FG, one thinks similarly the line BE, and instead of HI, one thinks KL, for these are related to each other as FA to BA. When the suggestion of the thing and the suggestion of time coincide, we have actual memory. When, however, one believes one does this without really doing it, one only believes that one remembers. For there is nothing to prevent one's being deceived and fancying that one remembers without this being actually the case. In actually remembering, it is impossible that one should not believe one is remembering, but should be unconscious of it. for this is just what constitutes memory. If, however, the suggestion of the thing and the suggestion of time are separated from each other, then no memory is awakened. The suggestion of time has a twofold meaning. Sometimes a thing is not remembered in determinate time, e.g., that day before yesterday one did something or other. In other instances, one remembers in terms of time measure. Memory, however, takes place even if one does not remember in the latter way. People are wont to say that they remember, although they do not know just when a thing happened, in cases where they are ignorant of the determinate measure of the when. We have already said that the same individuals are not endowed with good memory and good recollection. Recollection differs from memory not merely in the time element, but also because many animals share the endowment of memory, while none of the known animals, one may say, excepting man, is endowed with recollection. The reason for this is that recollection is a sort of syllogistic process. In recollection one reasons that one has known, or heard, or had some such experience of the thing in question, and the process is a sort of inquiry. And this is naturally found only in those creatures which have the power of deliberation, and deliberation is a kind of syllogistic procedure. That this condition affects the body, and that recollection is the search for an image in a corporeal organ, is proved by the fact that many persons are made very restless when they cannot recall a thing, and when quite inhibiting their thought, and no longer trying to remember, they do recollect nevertheless, as is especially true of the melancholic. For such persons are most moved by images. The reason why recollection does not lie within our power is this. Just as a person who has thrown an object can no longer bring it to rest, so too one who recollects and goes in search of a thing sets a corporeal something in motion in which the desired experience resides. Especially disturbed are such persons as have moisture about the region of sensation, for they do not easily come to rest after being stirred into motion until they attain the thing sought for, or the movement has taken its proper course. Consequently, the feelings of anger and fear, when they once set up a movement, do not cease, although opposing movements are started against them, but, on the contrary, persist towards their own aim. This affection resembles names, melodies, and words, when these are given violent utterance. For, after one has ceased, the singing or speaking recurs involuntarily. Further, those whose upper body is too large, and also dwarfish persons, have less power of recollection than those of the opposite physical structure, because the former are too heavy about the organs of sensation, and because the initial movements cannot persist, but are destroyed, and direct movement in the process of recollection cannot readily take place. Also, the exceedingly young and the very old do not recollect well on account of their movement, for the latter are in decline, and the former in rapid growth. Furthermore, children are like dwarfs until they advance in age. We have now treated the subject of memory and its process, its nature and the physical organ whereby animals remember, also the subject of recollection in its nature, its forms, and its causes. End of chapter 2 and end of On Memory and Recollection. Recording in memory of Mitchell Edwards. Chapter 1 of On Sleeping and Waking in Parva Naturalia by Aristotle, translated by William Alexander Hammond. This LibriVox recording is in the public domain. Recording by Geoffrey Edwards. Chapter 1. We must now consider the subject of sleeping and waking, and ask what they are, and whether they are phenomena peculiar to the soul, or common to the body and the soul. And if they are common, we must further inquire to what particular organs of the soul and body they belong. Further, we must inquire to what cause this animal function is due, and whether all animals share in both sleeping and waking, or are certain animals endowed with the one, and others exclusively with the other, or are there creatures that are endowed with neither of them, and others with both? In addition to this, we must investigate the nature of dreams, and explain why persons sometimes dream in sleep, and at other times do not. Or shall we say that dreaming always occurs in sleep, but we do not remember our dreams? If this is true, what is the explanation? A further question is whether or not it is possible to foresee future events, and if it is possible, in what sense are they foreseen? Further, is it possible to foresee only such future events as are performed by man, or also such as are caused by divine power? And does this foresight apply to what takes place in the course of nature, or to the results of accident? First of all, it is evident that both sleeping and waking are to be ascribed to the same organ, for they are contrary functions, and sleep is clearly the negative of waking. Now, contraries, whether in the realm of nature or elsewhere, are always expressed in one and the same organ capable of receiving them, and are affections of the same thing, I mean, e.g., health and disease, beauty and ugliness, strength and weakness, sight and blindness, hearing and deafness. This is further evident from the following. It is by the same sign that we recognize a person awake and one asleep. For when a person has sensation, we regard him as awake, and we believe that every waking person has sensation to a certain extent, either of the external world or of internal processes. If, then, waking consists in nothing else than in having sensation, it is evident that by virtue of that organ wherewith one has sensation, waking creatures are awake and sleeping creatures are asleep. But since sensation is not the function exclusively either of the soul or the body, for where there is potentiality, there is also a corresponding actuality, but what we understand by sensation in its actual sense is a physical process mediated by the body, it is plain that this phenomenon does not belong exclusively to the soul, and, on the other hand, it is impossible for an inanimate body to experience sensation. In earlier treatises, we have analyzed the parts of the soul, as we call them, and explained that the nutritive part is different from the other powers in animate bodies, although no other power can exist independently of it. From this it is evident that such living creatures as are endowed only with the functions of growth and decay do not experience sleeping or waking, as e.g. plants, for they have no organ of sensation, whether separated from or conjoined with the organ of nutrition. In potentiality and mode of expression, these two organs are separable from one another. It is likewise true that there is no creature that continuously wakes or continuously sleeps, but both these conditions are found in the same animals. If an animal has sensation, it is impossible that it should not sleep and wake. Both these phenomena refer to the experience of the primary organ of sensation. It is impossible that either of these conditions should be continuously found in the same creature, e.g., that any species of animal should sleep or wake constantly, because whenever we find a natural function, as soon as the time is exceeded during which the function is capable of being exercised, the organ necessarily becomes impotent, just as the eye, by exercising vision, becomes unable to perform this function. The same thing applies to the hand and to every other functioning organ. Now, if there is an organ to which the function of sensation belongs, and the time is exceeded during which continuous sensation is possible, then the organ will become powerless and no longer perform its function. If, therefore, waking is defined in terms of this condition, viz., as the release of sensation from a state of impotency, and if of two contraries one must always be present and the other absent, and if waking is the contrary of sleeping, and consequently one of the two must in every case be present, then sleep would be necessary. Consequently, if this is the nature of sleep, and it consists in a loss of power through excess of waking, and excess of waking is sometimes pathological and sometimes normal, so that the incapacity and its recovery would also have the character of the pathological and normal, it follows that every waking creature must also sleep, for continuous activity is impossible. So too there is no creature that can sleep continuously, for sleep is a condition of the sense organ which is like being fettered and held immobile. Every sleeping thing, therefore, must have a sense organ. By sense organ we mean that which has the capacity of actual sensation, but to have actual sensation in its proper and strict sense, and to sleep at the same time, is impossible. All sleep, then, must be a condition from which waking is possible. Almost all animals, whether their natural abode is the water, air, or land, evidently have the power of sleep, for we see all varieties of fishes and mollusks sleeping, and every other variety that has eyes, also the hard-eyed animals and the insects evidently sleep. The sleep, however, of all such animals is brief, and consequently an observer may not notice whether or not they share in sleep. In the observation of crustaceans it has so far not been clearly established whether they sleep or not. If, however, the foregoing reasoning is convincing, then one will believe that sleep occurs in this class. That all animals, therefore, share in sleep is proven from the foregoing. For the definition of animal is given in terms of the possession of sensation, and we define sleep as in a certain sense the immobility and fettering, as it were, of sensation, waking as the delivery and release from such condition. No plant can participate in either of these conditions, for without sensation neither sleeping nor waking occurs. Creatures that are endowed with sensation feel pleasure and pain, and when these are felt, desire is also felt. None of these phenomena, however, is found in plants. A proof of this is that the nutritive part performs its own function better during sleep than in a waking state, for at this time nourishment and growth are more rapid, which shows that for these purposes there is no need of the additional power of sensation. Chapter 2. We must now inquire why it is that sleeping and waking occur, and to what sense or senses, if there are several, they are due. Since some animals have all the senses and others not, e.g., some do not have sight, whereas touch and taste are universal, excepting in cases of abnormal creatures. And mention has been made of these in the treatise On the Soul. And further, since it is impossible for an animal in sleep to experience any sensation whatever, it is clear that we shall necessarily find this condition in all the senses during what we call sleep. For if an animal were to sleep in one part and not in another, then it would have sensation in sleep, which is impossible. Now, in every sense there is a power which is peculiar to it, and another power which it has in common with others, e.g., vision is peculiar to the eye, audition to the ear, and similarly peculiar powers belong to the other senses. But there is also a kind of common power that is associated with all the particular senses, by virtue of which one is conscious that one sees and hears. For by means of sight one does not perceive that one sees, and one discriminates and has the power of discrimination between sweet and white, not by virtue of taste or sight, nor by means of the two combined, but by means of a certain power which is common to all the sense organs. For sensation is unitary, and the master organ of sensation is unitary, although there is an essentially different character that belongs to each category of sensation, e.g. to sound and colour. This common element is allied more nearly to the tactual than to any other sense, for the tactual can exist apart from all the other sense organs, but the others cannot exist apart from it. This, however, was discussed in the studies on the soul. Sleeping and waking, then, are evidently an affection of this common sense, and are consequently found in all animals, for touch is the only universal sense. Now, if sleep consisted in the fact that all the senses undergo something, then it is remarkable that in cases where it is not necessary, or in a certain sense not possible, for them to be simultaneously active, yet these same senses should become simultaneously inactive and immobile. On the contrary, it is more plausible to suppose that they are not at rest simultaneously. But the explanation that we have given of these phenomena is a rational one. For when the master organ that rules over all the others, and to which all the others are directed, is affected, all the subordinate organs are necessarily affected with it. On the other hand, when one of the latter is disabled, it is not necessary that the master organ should be disabled also. But it is evident from many considerations that sleep does not consist in the inactivity and non-use of these special senses, nor in their incapacity to experience sensation. For this is just the sort of thing that happens in swooning. Swooning is the exhaustion of the senses. And there are also certain other kinds of mental disturbances that resemble this. Also, by compressing the jugular vein, one loses sensation. But whenever there is a loss of the use of sensation, it does not find its explanation in any chance sense, nor is it attributable to any haphazard cause. But the explanation is found, as we just now said, in the primary organ of all sensation. For when this is disabled, all the other sense organs are also necessarily unable to have sensations. When, however, one of these latter loses the power to act, the common sense is not necessarily disabled. We must inquire to what cause sleep is due, and what sort of an affection it is. Now, there are several kinds of cause. For we speak of cause in the sense of the end or purpose, again as the principle of motion, as the material condition, and as the notion or form. First of all, then, when we say that nature acts with a purpose, we mean that this purpose is some good, that rest is provided for every creature whose nature it is to move, and that, being incapable of constant and continuous pleasurable movement, this rest is a necessary and useful thing, and the metaphorical term rest is with perfect accuracy applied to sleep as repose. Consequently, sleep exists for the preservation of animals, and the waking state is its final cause and purpose. For sensation and thought are the final purpose of all animals that possess either of these powers. These are their highest activities, and the highest is the end. Sleep, therefore, is a necessity for every animal. I mean here a hypothetical necessity, viz., that if an animal is to preserve its nature, it must necessarily be provided with certain things, and where these things are found, other things are involved. We must next ask to what sort of bodily process and activity waking and sleeping are due. We must assume that the causes of sleeping and waking are the same, or analogous in bloodless and sanguineous animals, and in the lower sanguineous animals and men, so that what we observe in the case of man we shall have to apply to them all. It has been already determined in other treatises that the origin of sensation is found in the same organ from which motion originates. This organ is found in the middle division of the 3 topical sections of the body, and lies between the head and lower body. In sanguineous animals it is the pericardiac section, for all sanguineous animals have a heart, and this is the primary source of motion and of the higher sensation. Evidently, the origin of movement and of breathing, and in general of refrigeration, is found in this section, and it is also evident that nature created the organs of respiration and of refrigeration, which latter is effected by means of moisture, for the purpose of maintaining the warmth in this part. But this subject will receive separate treatment later. On the other hand, in the bloodless animals, the insects and such animals as are incapable of breathing air, there is found in an organ corresponding to the lungs congenital air which rises and falls. This is evidently true in the case of insects with undivided wings, such as wasps and bees, also in flies and similar insects. But since it is impossible to originate motion without power, the retention of the breath generates power. Breath derived from without in the case of respiring creatures, and congenital breath in the case of non-respiring animals. This is the reason why, as we see, winged insects buzz when in motion, the sound being caused by the friction of the air striking on the diaphragm of these Holoptera. Every creature experiences movement whenever a sensation, whether its own or caused from without, is awakened in the primary organ of sensation. Now, if sleeping and waking are affections of this organ, it is clear in what region and in what ultimate organ sleeping and waking have their origin. There are persons who are subject to movements in sleep, and do many acts that belong to the waking state, and nevertheless without any image or sensation. For the dream is in a certain way a sense-perception. About this we must speak later. Why it is that we remember our dreams on waking, while we do not remember acts done in a waking state, has been explained in the Problems. Chapter 3. Following upon what has been said, we have to consider to what occurrences the phenomenon of sleeping and waking is due, and what is its origin. Now, it is plain that as soon as an animal has sensation, it must at once take nourishment and grow. Food in its final state is, in all sanguineous animals, blood, and in bloodless animals something analogous to blood. The blood is contained in the veins, the origin of which is found in the heart, a fact which is demonstrated by dissection. When food has been introduced from without into those parts intended for its reception, an evaporation takes place in its transmission into the veins, and here it is transformed into blood, and is carried to its main organ. This subject was discussed in the treatise on food, but we must resume it now for the sake of observing the origins of animal movement, and of seeing to what affection of the organ of sensation waking and sleeping are due. For sleep is not any random exhaustion of the power of sensation, as said above. Senselessness, choking, and swooning produce a similar exhaustion. And in some cases of swooning there has been found even a strong power of imagination. Now this creates a problem, for if it is possible for a swooning person to fall asleep, then this imagination might be regarded as a dream. Also, people often talk when they are in a deep swoon, and are to all appearances dead. To all these cases of swooning, however, we must suppose that the same explanation applies. But, as we have said, sleep cannot be any and every incapacity to feel sensation. On the contrary, this particular condition springs from the evaporation of food. For the evaporation must be thrown off to a certain extent, and then it must return and change again, like the ebb and flood of a shifting strait. All animal heat tends to rise. When, however, it reaches the upper parts, it turns about and courses down again in mass. Consequently, sleep is most easily produced after taking food, for a large quantity of moist, crass matter is then carried to the upper parts. This, by remaining there, produces heaviness, and causes one to fall asleep. But when it descends, and in turning throws off its heat, then sleep ensues, and the animal slumbers. A proof of this is furnished by the action of narcotics, for they all, whether liquid or solid, produce heaviness, e.g. the poppy, mandrake, wine, and bearded darnel. And those who droop their heads and nod into slumber appear to be in this heavy condition. They cannot lift their heads or eyelids. Sleep of this sort follows mostly on the taking of food, for there is then a strong evaporation from food. It further arises from certain fatiguing efforts, for fatigue tends to waste, and waste matter is like indigested food, when it is not cold. Certain diseases, such as are due to an excessive amount of moisture or heat, produce this effect of sleep, as is the case, e.g., in fever and lethargy. Further, early infancy produces it, for children sleep a great deal, because all their food rises to the upper parts. A proof of this is seen in the excessive growth of the upper parts in proportion to the lower ones in early childhood, due to the fact that growth tends in that direction. It is to this cause also that epileptic conditions are due, for sleep is similar to epilepsy, in fact, is epilepsy in a certain sense, and so the beginning of this condition in many cases happens during sleep, and while asleep persons have an attack of it, but not while awake. For when a great mass of fumes is carried to the upper parts, in descending they press on the veins, and produce constriction of the passage through which respiration takes place. Consequently, wine is not good for children, or for wet nurses, for it makes no difference, perhaps, whether the wine is taken by the children or by the nurses, but they should drink it thinned with water and in small quantities. For wine contains spirituous fumes, especially wine of dark colour. In children, the upper parts become so full of food that during 5 months of life they cannot turn their necks, for a great quantity of moisture rises to the upper parts, just as it does in the case of persons who are very drunk. This phenomenon suggests a rational explanation of the fact that the embryo remains at first quiet in the womb. Also, in general, persons with deep-lying veins, of dwarf-like structure, and with large heads, are given to sleep, for the veins of the one class are small, and so the moisture in its downward course cannot readily flow through them, while in the case of persons of dwarf-like structure and large heads, there is a great pressure and evaporation towards the upper parts. Large-veined persons are not given to sleep because of the facility for the passage of blood in the veins, unless there be some adverse conditions present. Neither are the atrabilious especially inclined to sleep, for their internal parts are cool, and so no considerable evaporation takes place in them. Consequently, owing to their dryness, they are fond of eating, for the condition of their bodies is such that they seem to have eaten nothing, for the black bile, being in its nature cool, cools the nutritive region and the other parts, where this excretion of bile is potentially present. From the foregoing, one sees that sleep is an internal concentration of heat, and a natural reaction from the cause named. For this reason, a person in sleep moves a great deal. From the moment that the heat ceases to rise, however, the person becomes cool, and owing to the cooling the eyelids fall shut. And so the upper and outer parts of the body are cool, while the inner and lower ones, e.g. the feet, and the entrails are warm. Yet one might be in doubt as to the statement that the deepest sleep occurs after eating, that wine and other similar heating drinks are narcotic. To regard sleep as a cooling process is not reasonable. It is rather caused by heat. Or is one to suppose that analogously to the stomach, which is warm when it is empty, but as soon as it is filled becomes cool through its processes, so the channels and divisions of the head are cooled by the rise of evaporated matter? Or are we to suppose that analogously to persons pouring warm water over themselves and then suddenly shivering, so after the heat has risen, the collected cold produces a chill, and in this way counteracts the natural heat and drives it back? Again, when a large quantity of food is taken, which drives the warmth upward, the stomach is cooled until digestion takes place, just as fire is cooled when fresh wood is laid upon it. For sleep occurs, as we said, when crass evaporation under the influence of heat rises through the veins to the head. When this can continue no longer, because an excess of mass has been carried to the upper parts, then reaction takes place, and the evaporated matter flows back to the lower parts. Consequently, when the rising heat is withdrawn, men sink down. Man is the only animal that stands erect, and when the heat returns, it causes lapse of consciousness, and later awakens imagination. The explanation we have just given for the phenomenon of refrigeration is a possible one. The region about the brain, however, is the chief factor here, as we have said. The brain is the coldest part of the body, and in animals that have no brain, the part analogous to it is the coldest part. Just as water is evaporated by the sun's heat, and, when it rises into the upper air, is cooled by the air's temperature, and, condensed, falls to the earth once more in the form of water, so in the rise of heat to the brain the excessive evaporation is converted into viscid matter. For this reason, catarrhal affections appear to come from the brain, whereas the evaporation that assists nourishment and is normal returns to the lower parts condensed, and decreases the heat. The thinness and slender structure of the veins about the brain contribute to refrigeration and to the difficulty of their taking up the evaporation. This is the cause of refrigeration, even in cases where the evaporation creates an excessive degree of heat. Waking takes place when digestion has been completed, and the great amount of heat which is crowded into a small region out of the surrounding parts has gained control over the cold, and when further the crass blood has been separated from the purified blood. The thinnest and purest blood is in the head, the thickest and most turbid in the lower parts. The primary source of all blood is, as we have said in this treatise and elsewhere, the heart. Between the two chambers of the heart there is a middle chamber connected with both. The two chambers severally receive blood from the two arteries, from the great artery and the aorta, and the separation takes place in the middle chamber. The detailed treatment of this subject belongs, however, more properly to other treatises. On account of the unseparated character of the blood, after taking food, sleep occurs, and continues until the purest element is separated off and carried to the upper parts, and the more turbid element to the lower parts. When this is accomplished, sleepers are released from the heaviness caused by food and awake. The cause of sleep has, therefore, been explained as the reaction of crass vapour, which rises under the influence of its inherent heat on the primary organ of sensation. Sleep has also been explained as the inhibition of the primary sense organ, and its incapacity for function, and as a necessary phenomenon, for no animal can exist apart from the conditions which develop its nature, and sleep exists for the sake of preservation, for rest preserves. End of chapter 3, and end of On Sleeping and Waking. Recording in memory of Mitchell Edwards. Chapter 1 of On Dreams in Parva Naturalia by Aristotle, translated by William Alexander Hammond. This LibriVox recording is in the public domain. Recording by Geoffrey Edwards. Chapter 1. We must next investigate dreams, and inquire, first of all, in what part of the soul this phenomenon occurs, and whether it is an affection of the thinking power or of the sensible power, for it is solely by these two powers within us that we know at all. If the use of sight is vision, and of hearing audition, and of sense in general sensation, and, on the other hand, if there are common sensibles such as form, magnitude, number, etc., and particular sensibles such as colour, sound, flavour, and further, if it is impossible for any animal to see with its eyes closed and asleep, and if this applies equally to the other senses, then it is evident that we have no sensation in sleep, and so it is not by means of sensation that we experience dreaming. Neither are dreams mediated by opinion, for we not only say that an approaching object is a man or a horse, but also that it is white or beautiful, as to which qualities opinion, apart from sensation, makes no deliverances, whether true or false. However, this is just what the soul does in sleep, for, as in waking, so in sleep, we believe we see that the approaching object is a man, and that it is white. Again, we think of other things along with the dream, just as is the case with perception in our waking state, for we also often think about what we perceive. So in sleep, along with our imaginings, we sometimes have different thoughts. This would become apparent to any one who would give attention on rising and try to remember. There have been persons who have in this way observed their dreams, as e.g. those who try to arrange their deliverances in accordance with the precepts of the mnemonic art. For it often happens in their case that along with the dream they put something else, an image before their eyes, in the place in question, and so it is clear that not every image seen in sleep is a dream, and what we think conceptually we regard as true or false through the organ of opinion. So much is clear on this subject that the same agency which in disease produces illusion while we are awake, also produces the condition of illusion in sleep. Even when we are in sound health and know the truth, still the sun appears to us to be only a foot in diameter. But whether the soul's powers of imagination and sensation are the same or different, in any case, dreams do not take place independently of seeing and some sort of sensation. For illusions of sight and hearing occur when a person really sees and hears something, although not the thing that he thinks he sees or hears. In sleep, however, there is, according to the foregoing hypothesis, no seeing, no hearing, no sensation at all. The hypothesis that there is no vision is, therefore, untrue, and that sensation experiences no excitation is untrue. On the other hand, it is possible for sight and the other senses to undergo some change, and things impinge on each of them to a certain extent, as in the sensation belonging to the waking state, though with a certain difference. Sometimes opinion declares that the seen object is false, as in the waking state. Sometimes it is held in check and conforms to the imagination. Evidently, the affection which we call dreaming does not belong to opinion, or to the thinking part of the soul. Neither does it belong to the sense part unqualifiedly, for it would then be possible to see and hear unqualifiedly. But we must consider in what sense and in what way it attaches to the part. Let us take this evident fact for a starting point, that if sleep is a condition of the sensitive part, so is dreaming. For sleeping and dreaming are not ascribable to different animal organs, but to the same organ, inasmuch as we discussed imagination in the treatise On the Soul, and inasmuch as we find that the power of imagination is one with that of sensation, only that the mode of expression in the two cases is different, imagination being a process stimulated by an actual sensation, and since dreaming appears to be a form of imagination, for we call an imagination which we experience in sleep a dream, whether it is unconditioned or conditioned, it is evident that dreaming is a condition of the sensitive part, but of the sensitive part in its power to imagine. Chapter 2. We might best observe the nature of dreams, and the way in which they are caused, from the standpoint of what occurs in sleep. For sensible objects stimulate sensation in the several sense organs, and the mental condition produced thereby is not only present during the active process of sensation, but persists after the sensation has gone. The phenomenon here seems to be similar to that observed in the case of thrown objects. For in the case of a thrown object, the movement persists although the mover is no longer in contact with the thing. For the moving body communicates motion to a certain part of the atmosphere, and this in turn sets another part in motion. And in this way motion is caused both in the air and in water until the body comes to rest. One must suppose that something like this takes place also in qualitative change. A body that is warmed imparts by means of its heat warmth to the adjacent body, and this in turn distributes it further on until it reaches its terminal point. This, therefore, is what must take place in the organ wherewith we experience sensation, since actual sensation is a kind of qualitative change. Consequently, this condition is found in the sense organs, not only during the process of sensation, but also after the process has ceased, and in their inner depths as well as on the surface. This becomes evident when we have a sensation that continues over some time. For when we turn our senses to something else, the original sensation persists, as e.g. when we turn from the sun to a dark object. The result is that one sees nothing owing to the fact that the sense process stimulated by the light still lurks in the eyes. And if one looks a long time at a single colour, whether it be white or green, things appear to be similarly coloured wherever we turn our eyes. Again, if we look at the sun or some bright object and then shut our eyes, there appears to sharp observation, in the direct line which vision employs, first of all a colour like the actual one, which then changes to scarlet, then to purple, until it passes into blackness and vanishes. Also, the senses are affected in this way when they turn quickly from objects in motion, e.g. from looking at a river, and especially from looking at swiftly flowing streams. For objects at rest then seem to be in motion. And men are made deaf by loud noises, and their sense of smell is destroyed by strong odours, and so on. This evidently occurs as we describe it. That sense organs readily detect even minute distinctions is proven by the use of a mirror, concerning which fact one might stop at this point to investigate and make inquiries. From these inquiries it will at the same time become plain that just as sight is subject to an impression, so it exercises an activity. When women look into a very clear mirror after their menstrual flow, the mirror's surface becomes covered with a bloody cloud, and if the mirror is new, the stain is hard to remove, but if it is old, the removal is easier. The reason is that the eye, as we said, not only receives an impression from the air, but it also produces an impression and a movement, just as bright things do. For the eye is classed amongst objects that are bright and possess colour. Eyes are constituted in the same way, it is reasonable to suppose, as any other bodily organ, and so they naturally contain veins. When, therefore, the menstrual flow takes place, owing to disturbance and flow of blood, there is a difference in the eyes imperceptible to us, but nevertheless real, for the seed and the monthly flow have the same nature, and the air is set in motion by the eyes, and the air being continuous to the mirror, it imparts to the latter a certain quality, and an impression similar to the one it has itself received. The air affects the surface of the mirror, but as the cleanest clothing is the most readily stained, so it is here. For a clean thing shows exactly whatever taint it receives, even the slightest effects, more than other things do. Bronze especially, owing to its smoothness, is affected by every contact. We must regard the contact of air as a kind of friction, as cleaning or washing, and, owing to the purity of the bronze, this contact, however slight, becomes visible. The reason why stains are not readily removable from new mirrors is to be found in the fact that they are clean and smooth. For stains penetrate deep into such mirrors, and in every direction, for owing to the mirror's pure surface, the spots go deep, and owing to its smooth polish, they spread in all directions. In old mirrors the stain does not fasten, for it does not penetrate so deep, but stays rather on the surface. From these facts it is evident that movement is excited by slight distinctions, that sensation is swift, and further that the sense organ for colour not only receives impressions, but also reacts on external objects. Facts regarding wine and the preparation of ointments also furnish proof for these statements, for the prepared oil and wine readily take up the smells of adjacent objects, and they become tainted not merely with the smell of things thrown into them or mixed with them, but also of things that are placed or grow in their near neighbourhood. In reference to our original inquiry, let us lay down one fundamental truth, which is evidenced by what has been said, viz., that after the removal of the external sensible object, the experienced sensations persist. To this we must add that when under the influence of strong feeling we are easily deceived regarding our sensations, different persons in different ways, as e.g. the coward under the influence of fear, and the lover under that of love, have such illusions, that the former, owing to a trifling resemblance, thinks he sees an enemy, and the latter his beloved. And the more impressionable the person is, the less is the resemblance required. Similarly, everybody is easily deceived when in anger or influenced by any strong desire, and the more subject one is to these feelings, the more one is deceived. This is the reason why men sick of a fever sometimes think they see animals on the walls, owing to some slight resemblance in the figures drawn there. And this tendency to illusion at times keeps pace with the intensity of the emotional experience, so that in cases where the patient is not very sick, he is still conscious of the deception, but where his condition is more aggravated, he even rushes upon these animals. The explanation of this phenomenon is that the intellect and the faculty in which our images arise do not pass judgment with the same power. A proof of this is that the sun appears to us only a foot in diameter, and there is many another fact which contradicts our imagination. Also, by crossing the fingers, a single object under them appears to be two, and yet we do not say there are two, for sight is more decisive than touch. If, however, touch were our only sense, our judgment would declare that the single object is two. The source of illusion is found in the fact that things, whatever they may be, are perceived not merely while the stimulation of the sense object continues, but also during the further activity of the sense itself, if this movement is the prolongation of that awakened by the sensible object. I mean, e.g., the shore appears to sailors to move, although it is by something other than the shore that the eye is set in motion. Chapter 3. From these considerations it is clear that sense processes, whether arising from external objects or bodily activities, take place not merely during the waking state, but occur also in sleep, and that at this time they appear even more numerous. For during the day they are kept in the background by the combined activity of the senses and the intellect, and so are obscured, just as a small fire is obscured when placed alongside a larger one, or as trivial pleasures or pains are obscured alongside of great ones. But when the latter have vanished, then the smaller ones rise to view. At night, owing to the inactivity of the special senses and their incapacity to function, caused by the return flow of heat from the outer into the inward parts, these sense movements are carried to the primary seat of sensation, and become clear when the disturbance has subsided. And we must suppose, as tiny whirlpools occur in rivers, so each movement goes on continuously, frequently in the same direction, and again resolved into other forms through counter-influences. Consequently, after eating, and in the case of very young persons, as e.g. in children, dreams do not occur, for there is a strong movement excited by the heat in food. The case here is similar to what occurs in water when it is violently agitated, viz., sometimes no image is reflected, and sometimes only an entirely distorted one, so that the thing appears different from the reality. On the other hand, when the water is still, we see clear and distinct images. So too, in sleep, the images and residual movements resulting from sensations are sometimes entirely obliterated by a movement greater than the given one, and sometimes visions appear confused and monstrous, and the dreams are not marked by normal health, but are such as one finds in the atrabilious, in men sick of a fever, and in men that are drunken. For all these conditions are like flatulency, and excite great movement and disturbance. But when in sanguineous creatures the blood has come to rest and is separated off, the movement of sensation that proceeds from each sense organ and persists awakens normal dreams and causes an image to appear, and the person to believe that he sees something owing to the influences discharged from sight, and to hear owing to the influences discharged from hearing, and similarly with the other senses. For by the transmission of this movement from these special organs to the primary seat of sensation, one believes, in the waking state, that one sees and hears and perceives, and because it sometimes happens that sight seems to be stimulated without its being really so stimulated, we say that we see, and because touch reports two movements, we believe a single object to be two. In a word, the primary sense affirms the deliverances of the special sense, when no other more decisive sense contradicts this. There is without doubt an appearance, but what appears is not in every case believed, unless the power of judgment is inhibited or is not exercised in its normal way. But, as we said, that some persons are subject to illusion under one condition, and others under another, so when asleep one is deceived by the processes of sleep, by the excitations of the sense organs, and by other affections of sensation to such a degree that something which bears only a slight resemblance to a given thing is thought to be that thing. For when one is asleep, and the mass of blood recedes to the central organ, the movements in the blood, whether latent or actual, concentrate there. And the conditions here are such that, if the blood is stirred, a particular movement rises to the surface, and if this subsides, then another follows. They are related to each other like artificial frogs, which rise to the surface of the water as soon as the salt on them is melted off. And so these movements are latent in the blood, and as soon as the hindrance is removed, they come to active expression. When set free in the small amount of blood remaining in the sense organs, they stir themselves, exhibiting a likeness to things such as we see in clouds, which resemble men and centaurs in quickly shifting forms. Each of these images is, as we have said, the residue of actual sensation. After the true sensation has gone, the image continues, and it is correct to say that it is something like Coriscus, although not Coriscus. And at the moment of sensation, the master organ and judging faculty do not say that this is Coriscus, but only that owing to this sensation the real Coriscus is yonder person. On experiencing this sensation, the master sense makes the above deliverance, provided it is not entirely inhibited by the blood, just as without sensation this movement is set up by the processes latent in the sense organs. This latter, which resembles a thing, one then regards as the real thing. And the power of sleep is so great that it causes us to be unconscious of this difference. If one presses one's fingers under the eyes and does not notice it, a single thing not only appears double, but is believed to be so. If the pressure is noticed, the thing appears to be double, but is not believed to be so, and this is what happens in sleep. If a person perceives that he is asleep, and is aware of the sleeping condition in which the sensation occurs, then the appearance will be present indeed, but there is something in the person which says this is only a phantasm of Coriscus, and is not Coriscus himself. For there is often something in the soul of the sleeper which says that the appearance is only a dream. If, however, he is not conscious of the sleeping state, then nothing contradicts the imagination. That the above statement is correct, and that we have movements of imagination in the sense organs, becomes clear if in falling asleep and on waking we attentively try to remember what happens. For sometimes one will detect on waking that the images which appear in sleep are movements in the sense organs. In the case of certain young persons whose sight is thoroughly good, there appear before them, when it is dark, a multitude of moving images, so that they conceal themselves in fright. From all these facts one must conclude that a dream is a kind of sleeping phantasm, for the imaginings in children just referred to are not dreams, nor is anything else which is seen when we have the free use of our senses. Neither is every imagination that occurs in sleep a dream, for in the first place many persons have in sleep the power, in some form or other, of perceiving sound, colour, flavour, or touch, although the sensation is weak and seems to come from afar. Persons who are asleep and open their eyes slightly, and then suddenly awake, have discovered the reality of the lamplight, which in sleep they saw only, as they thought, in a glimmer, and hearing the faint crowing of a cock, or the bark of a dog, they have, on waking, recognized them as loud voices. Some persons even reply to questions. For it is possible that when one or the other of these states, waking or sleeping, is unquestionably present, the other may be present to some extent. In these cases there can be no dream, neither can such processes of real thought as occur in sleep along with fancies be called dreams, but a dream is that form of imagination that originates in the movement of sensation during the sleeping state as such. It has occurred in certain instances that men have never in their lives known themselves to have a dream. In other cases they have observed them when far advanced in years without having noticed them earlier. The reason why dreams do not occur in these cases seems to be closely allied to the reason which prevents their occurrence in children and after eating. For persons who are by nature so constituted that a large amount of vaporous matter ascends to their upper parts, or the return of this matter produces in them great movement, it is reasonable to suppose that in these cases there are no dream fancies. In advancing years there is nothing remarkable in the fact that dreams make their appearance. For where a certain physical change takes place, whether owing to age or to some internal affection, this changed condition regarding dreams must also occur. End of chapter 3 and end of On Dreams. Recording in memory of Mitchell Edwards. Chapter 1 of On Prophecy in Sleep in Parva Naturalia by Aristotle, translated by William Alexander Hammond. This LibriVox recording is in the public domain. Recording by Geoffrey Edwards. Chapter 1. Regarding prophecy in sleep, and the prophecy said to be derivable from dreams, it is difficult either to treat it with contempt or to believe in it. For the universal or widespread belief in the prophetic nature of dreams, based as it is on experience, lends support to this view, and it is not incredible that certain events are foreseen in dreams. There is a certain reasonableness in this, and so one might, in like manner, apply this belief to other dreams. The fact, however, that one cannot discover any intelligible cause for their occurrence creates distrust in them. The theory of divine origin is absurd, because in addition to its irrationality, one observes that these dreams do not come to the best and wisest, but to all sorts of men. But when their divine causation is excluded, there is no other reasonable origin that one can assign. For it seems to transcend our power of understanding to discover an explanation of the story that certain persons foretell the future through legends on the Pillars of Hercules or on the Borysthenes. Dreams, taken either in their entirety, or partially, or singly, must then be causes or signs of events, or else they must be accidental phenomena. Cause I understand in the sense of the moon's being the cause of the sun's eclipse, and fatigue being the cause of fever. By sign I mean e.g. that a sign of an eclipse is a star's becoming visible in daylight, or the roughness of the tongue in fever. By an accidental phenomenon I mean e.g. that an eclipse of the sun happens while one is taking a walk, for taking a walk is neither sign nor cause of an eclipse, neither is an eclipse the sign or cause of taking a walk. Consequently, no accidental phenomenon takes place constantly, or even as a rule. Is it then possible that some dreams are causes and others signs, e.g. of physical events? Well-educated physicians, at any rate, say that we should pay close attention to dreams, and this view is also regarded as reasonable by laymen who are investigators and philosophers. For the physical movements that occur by day, unless they are very full and vigorous, are unnoticed when they are experienced along with greater waking excitations. In sleep, however, the reverse is true. for then the trivial movements seem to be the important ones, as is apparent from frequently observed facts regarding sleep. When slight noises fall upon the ear, one thinks it lightens and thunders, and when a bit of mucus flows into the mouth, one thinks one is tasting the sweet flavour of honey, and when a very slight heat is felt in any member, one thinks one is walking through fire, and is fever hot. But when one awakes, one discovers the real facts. Since, then, all beginnings are small, it is evident that the beginning of disease and other bodily affections on the point of development will be small, and these necessarily show themselves more in sleep than in the waking state. Yet it is really not unreasonable to suppose that certain sleeping fancies are causes of actions peculiar to the individual. For when we are on the point of doing something, or are in the midst of it, or have accomplished it, it frequently happens that we are occupied and busy with the same thing in a distinct dream, the explanation of which is that the dream movement has been already started from origins in the day's activity. And as this is true, so the converse must be true, viz. That the movements in sleep are often the starting points for the activities of the day, because the thought for the latter is already started on its way in our nocturnal fancies. In this sense, therefore, certain dreams may be signs and causes, but most prophetic dreams are things of chance, especially all those that transcend us and whose origination is not in our power, as e.g. a naval battle and remote events. The situation here is just like that of a man who thinks of a thing, and in that instant the thing appears. For what is there to prevent this being also true of dreams? It is even more likely that many accidents of this sort should occur here. Just as, in the former case, thinking of a thing is neither sign nor cause of the thing's appearing, so here the beholder's dream is neither sign nor cause of the event, but only accident. Consequently, most dreams do not come true, for chance is that which occurs neither constantly nor even as a rule. Chapter 2. Since other animals than man have dreams, one may say, in a word, that dreams are not sent from God, and do not occur for his ends. They are, however, demonic, for their nature is demonic, but not divine. This is proven by the fact that very ordinary men have prophetic visions and true dreams, showing that God does not send them. But such men as have a loquacious and atrabilious nature see all sorts of visions, and because these excitations are many and diversified, they chance upon thoughts which correspond with reality, hitting the right thing here, just as one sometimes hits in the game of odd and even. For in this instance the proverb applies, who often shoots will sometimes hit. That many dreams do not come true is not strange, for even the signs in physical and heavenly processes, such as the signs of rain and wind, often fail. For if another movement sets in which is stronger than the one indicated, the indicated event does not take place. Also, many well-matured plans of what ought to be done fail of execution because other more important motives arise. For not every expected event occurs, and one must not identify the future with the expected. Nevertheless, one must say that there are certain causes to which this lack of fulfilment is due, and these are natural signs of the non-occurrence of the given events. In regard to dreams which are not due to such origins as we have mentioned, but to origins that either in point of time, place, or magnitude are extraordinary, or which are not to be described in this way at all, and yet the dreamer does not have in himself the cause, in these cases, unless the prophetic character is accidental, it would be better to explain such foresight in the following way, rather than in the way employed by Democritus, who explains them by images and effluxes. Just as when water or air is stirred, the stirred part sets another part in motion, and after this has come to rest, a similar motion is continued up to a certain point, even in the absence of the moving agent. So nothing prevents a certain movement and sensation from reaching the soul in sleep, produced by those objects from which Democritus says images and effluxes are thrown off. And these movements, reaching the soul in some way or other, are more distinctly felt at night, because they are more readily dissipated when they enter by day. For the night air is less apt to be disturbed, owing to the calmer nature of night. And they awaken sensation in the body on account of sleep. For persons when asleep detect slight internal processes more sharply than when awake. These movements awaken fancies out of which one foresees the future in events similar to the fancies. This power of prevision, then, occurs in any ordinary person, and not in the wisest. For if prevision were sent of God, it would come by day and to the wise. In this manner, however, it is reasonable that prevision comes to ordinary men. For the minds of such persons are not given to careful thought, but are, as it were, reft and empty of all content, and when stimulated, they follow the lead of the moving agent. The reason why certain persons afflicted with ecstatic mania have prevision is that their own excitations do not distract them, but are rather thrown off by them, and therefore they have a special perception of processes foreign to them. That some persons have true dreams, and that familiar acquaintances have prevision, especially regarding each other, comes from the fact that acquaintances concern themselves most about each other. For just as it is most true of intimate friends that they recognize and see each other at a distance better than others do, so it is also with these movements. For the movements of acquaintances are more easily recognized. The atrabilious, like long-distance throwers, owing to the vehemence of their natures, hit their aim, and owing to their mobile disposition, they have a quick fancy for sequence. For as Philagades in his poems, and insane persons, recite and think out sequences that depend on similarity, as illustrated in the Song of Aphrodite, so these dreamers string together a series of events. For, owing to their passionate nature, they are not swerved aside by extraneous movements. The most skilful interpreter of dreams is he who can discern resemblances. For a plain dream can be interpreted by anybody. By resemblances I mean, as I said before, that the pictures of imagination are very like pictures in the water. In the latter, when the movement is violent, the reflection and picture bear no resemblance to the reality. And so a clever interpreter is one who can quickly distinguish and see at a glance in the confused and distorted picture the suggestion of a man, or horse, or whatever the given object may be. And as the picture in the water, so the dream can be similarly distorted, for movement destroys the distinctness of dreams. We have now explained the nature of sleep and dreams, and have given the cause of their occurrence, and have further explained the entire subject of divination by means of them. End of chapter 2, and end of On Prophecy in Sleep. Recording in memory of Mitchell Edwards. Chapter 1 of On Longevity and Shortness of Life in Parva Naturalia by Aristotle, translated by William Alexander Hammond. This LibriVox recording is in the public domain. Recording by Geoffrey Edwards. Chapter 1. We must now inquire into the causes why some animals live long and others only a short time, and into the general subject of longevity and shortness of life. The initial point in our inquiry must be the stating of certain preliminary problems touching these phenomena. For it is not clear whether or not the cause of longevity and shortness of life is the same in animals and plants. Some plants are annuals, and others attain great age. Further, one may ask whether amongst the creatures of nature the long-lived and the naturally healthy are identical. Or is shortness of life to be kept distinct from questions of disease? Or is it true that some diseases cause the body whose nature is affected to be short-lived, while other diseases in no wise prevent long life? Regarding sleeping and waking we have already spoken, and we must later on treat the subjects of life and death, and likewise disease and health, so far as they fall within the province of the philosophy of nature. At present we have to consider, as already said, the causes of longevity and shortness of life. This distinction of longevity marks entire genera in comparison with others. And again it marks certain members of one species in comparison with other members. By this I mean there is a generic difference in longevity applicable, e.g., to man and horse, for the genus man is longer lived than the genus horse. And again, within the species, one man is longer lived than another, for some men are long-lived and others short-lived, according to the districts they inhabit. Nations that inhabit warm countries live longer. The inhabitants of cold countries are less long-lived. And amongst those that inhabit the same locality, there are also between individuals differences in this respect. Chapter 2. We must understand what is easily destroyed in natural structures, and what is destroyed with difficulty. Fire and water, and other elements akin to them, without having their power, are, in their reciprocal action, the causes of generation and decay. Consequently, everything else one may reasonably suppose that is derived from or composed of these elements shares in their nature, excepting such things as are artificially composed of a great many parts, like a house. The discussion of these other elements does not belong here. Many things are subject to destruction from causes peculiar to themselves, as e.g., knowledge, health, and disease. For these are destroyed when the things of which they are qualities are not destroyed, but survive, e.g., the agency which destroys ignorance is recollection and learning. The agency which destroys knowledge is forgetfulness and error. Accidentally, the destruction of other properties goes hand in hand with the destruction of the natural body. For when animals are destroyed, the knowledge and health that are in them are also destroyed. From this one might draw a conclusion regarding the soul. For if the soul is not in the body by natural growth, but is there just as knowledge is in the soul, then it would be exposed to another destroying agency in addition to that to which it is liable in the destruction of the body. But this does not appear to be the case. The relation between soul and body must be differently understood. Chapter 3. Perhaps one might reasonably ask the question, is there any place where the perishable is imperishable, as in the case of fire in the empyrean, which is subject to no opposing influence? For the properties that attach to opposites are incidentally destroyed by the destruction of the thing itself. For opposites destroy one another. No opposite, however, which belongs to substance is incidentally destroyed, for substance is not predicated of any subject. Consequently, in whatsoever thing there is no principle of opposition, and where there is no such principle, there can be no destruction. For what is there to work destruction, if destruction is effected exclusively by opposites? But there is no opposition present, either absolutely or in any particular part. Or is this true in one sense and in another false? For whatever has matter cannot avoid being in some sense subject to opposition. It can be everywhere hot or straight, but it cannot be in its entirety hot or straight or white, for these qualities would then be separate entities. Whenever the active and passive come together, if the one always acts and the other is always acted upon, change must take place. Further, if change necessarily produces a residue, then residue involves opposition, for change is always the result of opposition, and residue is that which remains from a state prior to change. But if the actually opposed were entirely excluded, a thing would, in this case, be imperishable. Or is this untrue? But a thing in this event would be destroyed by its environment. If this happens, then the above explanation is adequate. If the destruction is not so produced, one must suppose there is an actual inherent opposition in the thing, and that a residue is produced. For this reason, the lesser flame is incidentally consumed by the larger one, because the food which the smaller one consumes in a long time in the form of smoke is consumed by the larger one quickly. And so everything is in constant motion, constantly coming into existence and passing out of existence, and the environment either assists or opposes. Constantly changing things may last a longer or a shorter time than their own nature prescribes, but nothing lasts forever where opposites exist. For, at the very start, matter contains in itself the principles of opposition, so that if one employs the category of place, spatial change is involved. If one employs the category of quantity, we have changes of growth and decay. If one employs passivity, then qualitative change. Chapter 4. Neither are the largest creatures less exposed to destruction than others, for the horse is shorter lived than man, nor the small animals, for many insects live only a year. Nor in general are plants longer lived than animals, for some plants are annuals. Nor are sanguineous animals, by virtue of their being sanguineous, long-lived, for bees live longer than do certain sanguineous animals. Neither are the bloodless animals, as such, long-lived, for molluscs, which are bloodless, live only a year. Nor land animals, for there are both plants and land animals that live only a year. Nor sea animals, for the crustaceans and molluscs are short-lived. On the whole, the longest-lived organisms are found amongst plants, an example of which is the palm. Next, the sanguineous live longer than the bloodless animals, and the land animals longer than those that live in water, so that the longest-lived animals are those where we find the combined marks of having blood and living on the land, as instanced in man and the elephant. It is a rule also that the larger animals are longer lived than the smaller ones, and this characteristic of size applies to other examples of longest-lived animals, as well as to the instances cited. Chapter 5. The cause of all this might be discovered in the following facts. One must understand that an animal is by nature moist and warm, and life is also moist and warm, whereas old age is dry and cold, and so is death. And this is plain to observation. The matter in living bodies has these qualities of warm and cold, dry and moist. As beings grow old, they must then dry up, and so the moist should be constituted in such way as not to dry up easily. Now, fatty elements do not readily decay. The reason is that they contain air, and air, compared with other elements, is fire. But fire is not subject to decay. The amount of moisture should not be small, for a small amount is quickly dried out. Consequently, larger animals and plants are, as a rule, longer lived than others, as we said before. For it is reasonable to suppose that the larger creatures possess a greater supply of moisture. But it is not merely for this reason that they are longer lived. For there are two causes of long life, a quantitative and qualitative cause. consequently there must not merely be a certain quantity of moisture present, but this must also be warm, in order that it be not easily congealed or dried up. It is for this reason that man is longer lived than certain larger animals. For animals that are defective in the mass of moisture are longer lived, provided their excess in the quality of this moisture is relatively greater than their defect in its quantity. Some animals have an oily warmth, in consequence of which their moisture is not easily dried up or chilled. Others again have a moisture of a different sort. Further, whatever is meant to be difficult to destroy should not throw off much residue, for this, whether it be due to disease or to nature, destroys a thing. Residue has the significance of opposition, and is destructive of a thing either in its entire nature or in some part of it. Consequently, salacious animals and such as abound in seed age quickly, for seed is a residue, and when it is thrown off produces dryness. For this reason a mule lives longer than a horse or an ass, and women live longer than men in cases where men are lascivious, and so male sparrows are shorter lived than females. Further, males subjected to hard labour are short-lived, and on account of toil age more rapidly. For toil produces dryness, and old age is dry. In the ordinary course of nature, and taking it all in all, men live longer than women. The reason for this is that the male is a warmer animal than the female. The same classes of animals live longer in a warm than in a cold climate, for the same reason that the larger animals live longer than smaller ones. Particularly striking in this connection is the size of the naturally cold animals. So snakes, lizards, and rough-scaled reptiles found in warm localities, and the testacea of the Red Sea attain a great size. For warm moisture is the cause of growth and life. In cold districts, animal moisture is more watery and consequently easily congealed, so that animals with little or no blood, whether their habitation is the land or water, do not occur at all in the northern regions, or if they occur, they are smaller and shorter lived, for frost impedes growth. Both plants and animals perish when they get no nourishment, for then they consume themselves, just as a larger consumes and destroys a smaller flame by using up its food, so the natural warmth, whose primary function is digestion, consumes the matter in which it is found. Aquatic animals are shorter lived than land animals, not because they are moist unqualifiedly, but because they are watery. Moisture of this sort is very perishable, because it is cold and easily congealed. For the same reason, the bloodless animal is very perishable, unless it is protected by great size, because it contains no oily or sweet element. I say sweet, for animal fat is sweet. Consequently, bees are longer lived than other animals that are larger. Chapter 6. It is amongst plants that we find the longest lived organisms, and these attain a higher age than animals, in the first place because they are less watery, and therefore not easily congealed. Secondly, they contain a viscous oily substance, and therefore, although they are dry and earthy, they nevertheless possess a moisture which is not easily dried out. We must now find an explanation for the great age attained by trees, for a peculiar explanation applies to them which does not apply to animals, excepting insects. This peculiarity is that plants constantly renew themselves, and so attain great age. For new shoots are put forth from time to time, and others grow old, and the same thing is true of the roots. But this renewal does not take place in all parts at once. Sometimes only the trunk and branches die, and others grow up alongside of them. And when this happens, other roots spring from the remaining part. And so it continues, one part passing out of existence, and another part coming into being. Consequently, they live long. Plants have a resemblance to insects, as already said. For life continues when they are divided, and out of one insect or plant, two or several are produced. Divided insects, however, reach merely to the state of living, but are not able to continue long in life, for they have no organs, and the principle of life in the single part has no power to develop an organ. This principle in the plant, on the contrary, has the power of developing organs, for it contains in every case both root and stem potentially. Consequently, the new and the aging branch keep growing from this, differing little in their length of life, just as it is with grafts. In the grafting of shoots, one would say that, in a certain sense, the same process occurs, for the shoot is part of a plant. In the grafting of shoots, however, the continuity of life occurs in a state of separation from the mother plant, while in the other cases the lives are conjoined. The reason is that the inherent potential principle in the plant is all-pervasive. There is, however, a point of identity between animals and plants. In animals the males are, as a rule, longer lived than the females, for their upper parts are larger than the lower ones. The male is more dwarf-like than the female. The warm element is found in the upper parts, and cold in the lower ones. Also, plants with large roots are longer lived than the others. Annuals are not of this kind, but trees are, for the upper part and head of a plant is the root, but annuals have their main growth towards the lower parts and the fruit. These questions will be examined in detail in the treatise on plants. For the present, we have explained the cause of longevity and shortness of life in animals. There remain for our consideration the subjects of youth and old age, life and death, and after these have been investigated, our treatise on animals will have been finished. End of chapter 6. And end of On Longevity and Shortness of Life. Recording in memory of Mitchell Edwards. Chapter 1 of On Youth and Old Age and On Life and Death in Parva Naturalia by Aristotle. Translated by William Alexander Hammond. This LibriVox recording is in the public domain. Recording by Geoffrey Edwards. Chapter 1. We must now treat of youth and old age, and of life and death. At the same time, it may be necessary to explain the causes and conditions of respiration. For in some animals, life and death are conditioned by respiration. We have elsewhere treated more precisely of the soul, and it is clear that its ultimate nature cannot be corporeal, although it has its seat evidently in some part of the body, and in some part too that has a higher importance amongst the body's members. For the present we must dismiss the other parts or powers of the soul, whatever may be the proper term to apply to them. In regard to creatures that are termed animals and have life, in cases where they are endowed with both attributes, I mean with animality and life, it must be that the principle whereby they live, and by virtue of which they are called animal, should be one and the same part. For it is impossible for an animal, as animal, not to have life. On the other hand, it is not necessary for a thing to be an animal because it has life. For plants live, and yet they have no sensation, and it is in terms of sensation that we distinguish the animal from the non-animal. Numerically, they are one and the same part, although in their mode of expression they are manifold and different. For it is not the same thing to be an animal and to have life, since amongst our sense organs there is one which we call a kind of common sense, where all our actual sensations must come together. This common sense must occupy a position midway between what we call the anterior and posterior parts of the body. By anterior is meant that which is situated towards the region of sensation, and by posterior that which is situated in the opposite region. Furthermore, since in all living organisms the body is divided into an upper and lower half, for all animals as well as plants have an upper and lower part, the nutritive principle should evidently occupy a position midway between them. The part which contains the organ for admitting food is called the upper part, and we use the term 'upper' here in reference to the body itself, and not in reference to the directions of the surrounding universe. By 'lower' we mean the part whose primary function is to void excrement. In this connection we find a wide difference between plants and animals. In man, more than in any of the other animals, owing to his erect attitude, we find the upper part turned towards the upper part of the universe. In the other animals, the upper part is turned in a direction midway between the upper and lower parts of the universe. In plants, which are fixed on one spot and draw their nourishment from the earth, this upper part must in every case have a downward direction. For roots in plants and mouths in animals are analogous organs, by means of which in the one case food is derived from the earth, and in the case of animals through themselves. Chapter 2. All perfectly developed animals are analyzable into three parts: one for the admission of food, a second for the voiding of excrement, and a third midway between these two. The last of these is called in larger animals the chest, and in the smaller some equivalent term is used. In some animals, however, it is more clearly articulated than in others. Again, such animals as are capable of progressive motion have, in addition to the parts mentioned, other organs adapted to the service of movement and to carrying the entire trunk, as legs, feet, and other organs that have the same function as these. The nutritive principle of the soul is situated in a region central to these three parts, as is evident both from observation and reason. In fact, there are many animals which, after one or the other part has been cut off, even the head and the organ for seizing food continue to live in that part to which the middle is conjoined. This fact may be plainly observed in the case of insects, such as wasps and bees. Also, many animals besides insects, when cut in two, can continue to live by the functioning of the nutritive principle. This nutritive part is actually unitary, but potentially multiple, and the natural construction of these animals is the same as that of plants. For plants, after they are divided, continue to live in segments, and from a single origin one can by section produce several trees. Why it is that some plants cannot continue life after section, while others can be propagated, must be explained elsewhere. In this respect, however, plants and insects as a class are alike. It is necessary that the nutritive principle in those living things that possess it should be actually one, though potentially multiple, and the same holds good of the principle of sensation, for the segments evidently have sensation. In reference to the maintenance of their natural life, plants, when divided, are able to survive. Animals are not, for they lack organs for their preservation, wanting in some instances organs for the seizure of food, and in others for receiving it into the body, and in other instances wanting other organs in addition to both of these. Such divisible animals resemble a complex of several creatures grown together. In the most perfectly organized bodies, however, this phenomenon is not found, because their natures have been fashioned into the greatest possible unity. There are always, however, certain dissected members which exhibit slight sensation because they are still under the influence of a certain physical affection. For, after the entrails have been removed, bodily movements are still continued, as one observes in tortoises after the removal of the heart. Chapter 3. We have further proof of the central situation of the nutritive principle in the case of both plants and animals. In the case of plants, we observe their generation from seeds, and we also note the phenomena of grafts and slips. Generation from seeds takes place in every instance from the centre. All seeds are bivalvular, and the point at which their two halves are joined is the point from which generation begins, and the middle in reference to the two parts. It is from this point that stem and root shoot forth in growing plants, and the point of origin is also the central point. This phenomenon may be observed in the case of the buds of grafts and slips, for the bud is in a sense the life principle of the branch, and at the same time its centre. It is the bud, therefore, which one removes, or into which one inserts a graft, in order to produce branch or root from it, on the theory that the origin of life in branch or root is the centre. In sanguineous animals, the first organ in development is the heart. This is plainly seen in those animals whose process of generation admits of observation. In bloodless animals, the organ that is analogous to the heart must be the first developed. We have already said in our earlier treatise on the parts of animals that the heart is the organ from which the veins proceed, and that the blood in sanguineous animals is the ultimate source of nourishment, out of which the members are generated. Although, regarding nourishment, it is plainly the office of the mouth to perform one certain task, and the office of the stomach to perform another task, yet the heart is the master organ, and sets the end for all the others. Consequently, in sanguineous animals, it is in the heart that we must look for the origin of nutrition and sensation. For, regarding the preparation of food, the functions of the other organs are subordinate to the function of the heart. It must be true that the master organ is that which works persistently towards the end, and does not stop with that which is subordinate to the end, just as a physician persistently works towards health. At any rate, the dominating organ of sensation in all sanguineous animals is found in the heart, for the common sense which serves all the special senses must be situated there. There are two senses, taste and touch, whose channels lead manifestly to the heart, and what is true of these must be true of the other senses. Movement in the other sense organs may be transmitted to the heart, but with the upper parts of the body, these two senses, touch and taste, do not communicate at all. Apart from these considerations, if the life principle in all animals is situated in the heart, the sensory principle must evidently be found there also. For that by virtue of which we call a thing an animal is the same as that by virtue of which we say that it lives, and the differential mark of sensation is the same as the differential mark of a living body. The reason why certain senses are, as we see, connected with the heart, and others with the head, in consequence of which some philosophers regard the brain as the organ of animal sensation, has been given in a separate treatise. Chapter 4. From what we have said, based on observed facts, it is clear that the principle of sensation, as well as that of growth and nutrition, is situated in this organ, the heart, and in the middle of the three divisions of the body. On the basis of deduction, we should say the same thing, because we see that nature, out of existing possibilities, does in every instance the best. Now, if each principle is situated in the central section, the parts, viz., that which finally elaborates the food and that which receives it, would thus perform in the best possible way their several functions. For to each of the parts the central organ will then be so related as is best. And the mid-position in a case such as this is the position that naturally belongs to a ruling principle. Again, one must make a distinction between the user and the instrument used, and as they differ in function, so too, if possible, they should differ in position, as a flute and the hand that plays it are different in function and situation. If then to be an animal means to have the power of sensation, this power, in the case of sanguineous animals, must be found in the heart, and in bloodless animals in a corresponding organ. every member and the entire animal body possess to a certain degree congenital heat. Consequently, we see that during life animals are warm, but when dead and deprived of life they are cold. The source of this heat in sanguineous animals must be sought in the heart, and in bloodless animals in the analogous organ. For all the organs, especially the dominating one, prepare and digest their food by means of natural heat. Consequently, all the other parts of the body may become cold, and yet life may continue. But when the master organ becomes cold, life is destroyed entirely, because this is the source of heat for distribution to all other organs, and the soul is as it were suffused with fire in this organ, which in sanguineous animals is the heart, and in bloodless animals an organ analogous to the heart. Life, then, must go hand in hand with the continuance of this heat, and what we call death is its discontinuance. Chapter 5. There are two ways in which, as we see, fire may be extinguished, viz., it may either go out or be put out. In the former case, we say the extinction is caused from within. In the other case, it is caused by opposing forces. An example of the former is old age, of the latter, external violence. Extinction in both cases, however, is due to the same ultimate cause, viz., the failure of fuel, for when fuel fails and the heart can no longer receive sustenance, extinction of the fire ensues. Cold, by retarding digestion, arrests nourishment, and there are times when it extinguishes itself, as e.g. when the heat is massed in too great quantity, owing to lack of respiration, or lack of cooling, and when the heat accumulates in such mass, it soon causes an exhaustion of fuel, and this process of exhaustion takes place before evaporation has time to develop. Not only, then, is a smaller fire extinguished by a larger one, but also the flame of a lamp is consumed within itself when immersed in a large flame, just as any other combustible would be consumed. The reason for this is that the larger flame uses the fuel contained in the smaller before other fuel can take its place, and the fire continues in constant process of development, and in constant flow like a river. But we do not observe this on account of its rapidity. It is clear, then, that if the heat is to continue, and this is necessary if life is to continue, there must be some means of reducing the heat in the chief organ. An illustration of this may be had in what takes place in quenched coals. For if coals are kept closely covered in a common oven, the fire is quickly extinguished. Whereas, if one in rapid alteration removes the lid and sets it on again, the coals continue lighted a long time. Covering a fire with ashes also keeps it, for, owing to the porosity of the ashes, ventilation is not prevented, and the ashes, by admitting the surrounding air, protect the fire against extinction through excess of heat arising in it. However, the explanation of the fact that opposite effects are produced by covering a fire with ashes and with an oven lid, for the latter extinguishes it and the former keeps it a long time, has been given in our treatise on problems. Chapter 6. Since every living thing has a soul, and the soul, as we have said, cannot subsist without natural heat, we find that in plants adequate provision has been made for the preservation of natural heat through nutriment and the surrounding air. For food produces refrigeration in organisms when it is first introduced, just as on its entrance it does in man, whereas fasting creates heat and produces thirst. For air, when it is stagnant, always becomes heated, but when set in motion through the admission of food, it is cooled until the food has undergone digestion. On the other hand, if the surrounding air is excessively cold, owing to the season and the occurrence of heavy frosts, plants are dried up, or if intense heat occurs in summer and the moisture derived from the soil is inadequate for refrigeration, the natural heat is extinguished and destroyed. In such seasons one says that trees are frosted or suffer blight, and that is the reason why people pile certain kinds of stones about the roots or cover them with vessels of water, in order to keep the roots of the plants cool. In the case of animals, since some of them are aquatic and others live in a medium of air, the refrigeration is derived from and through the media in which they live, i.e. in the one case water, and in the other air. We must now begin a special inquiry touching the nature and manner of this process. End of chapter 6 and end of On Youth and Old Age, Life and Death. Recording in memory of Mitchell Edwards. Chapter 1 of On Respiration in Parva Naturalia by Aristotle. Translated by William Alexander Hammond. This LibriVox recording is in the public domain. Recording by Geoffrey Edwards. Chapter 1. A few of the earlier physicists have treated the subject of respiration, but in regard to the purpose which it subserves in the animal organism, some of them have given no explanation whatever, and others, although they have discussed it, have been wrong in their statements and have lacked empirical knowledge of the facts. Furthermore, they declare that all animals respire. This, however, is untrue. It will be necessary, therefore, to return to these points in order that we be not thought to make unfounded charges against writers who are no longer living. It is plain that all animals with lungs breathe, but amongst these, the animals that have a spongy, anemic lung need respiration less than the others. Consequently, they can remain, owing to their physical strength, a considerable time under water. All oviparous animals have a spongy lung, as is the case in frogs. Again, water tortoises and land tortoises can remain a long time under water. In these animals the lung has little heat, because it has little blood. Consequently, when it has been once inflated, it effects refrigeration by its motion, and enables the animal to continue a long time under water without breathing. Even in these cases, however, when the animal is forced to hold its breath too long, it is suffocated, for none of these animals can inhale water, as fishes do. All animals, on the other hand, whose lung is full of blood, have greater need of respiration, because of their greater heat. As to the animals that have no lung at all, they have no respiration at all. Chapter 2. Democritus of Abdera and certain other writers on the subject of respiration have not spoken definitely about the animals last named, but they appear to assert that all animals breathe. Anaxagoras, however, and Diogenes make the statement that all animals respire, and they say that fishes and oysters are endowed with a sort of respiration. Anaxagoras declares that when fishes discharge water through their gills, they inhale the air that is developed in the mouth, for a vacuum does not exist, and so respire. Diogenes, on the other hand, says that when fishes discharge water through their gills, they inhale air by the action of the vacuum formed in the mouth, out of the water which surrounds the mouth, on the theory that water contains air. These views, however, are untenable, for, in the first place, they leave out of account half of the truth, because their entire statement refers only to one aspect of the case. For by respiration one understands partly inspiration and partly expiration, and they have nothing to say in explanation of how the latter takes place in lungless animals. And it is impossible for them to give any explanation. For when inspiration takes place, expiration must also follow by the same channel as that employed in inspiration, and these two things must succeed each other in constant alternation. The consequence is that exhalation must take place at the same moment that water is being received into the mouth, and in that case the one must impede the other by meeting. Secondly, if they exhale by the mouth or gills, at the moment when they discharge water, the consequence will be that inspiration and expiration will be simultaneous, and, according to the above assertion, this is the moment in which animals inspire. But simultaneous inspiration and expiration is an impossibility. Consequently, if it is true that respiration involves both inspiration and expiration, and if it is further true that aquatic animals are not capable of expiration, it is clear that they are also incapable of respiration. Chapter 3. Again, the assertion that they inhale air from the mouth, or from the water through the mouth, is impossible. For aquatic animals have no windpipe, because they have no lung, but the stomach is immediately adjacent to the mouth, and consequently the stomach would necessarily be the organ of inspiration. But if this were true here, the stomach would have this power in other animals also. As a matter of fact, it does not have this power. Further, if aquatic animals were removed from the water, they would then clearly show this capacity to respire, but they do not show it. Furthermore, we observe in those animals that respire and inhale air a certain movement in the organ of inhalation. This is not observable in fishes. They appear to move no organ about the stomach other than the gills, whether they are in the water or are thrown gasping on the dry shore. Again, when any respiring animal dies from suffocation in the water, its breath, as it forcibly leaves the body, is formed into bubbles, as one sees in the case of tortoises or frogs, or other animals of this sort, when they are forcibly drowned. With fishes, however, this is not the case, whatever method one may use, because they contain no inhaled air. According to the explanation of respiration above mentioned, it would be possible also for men to respire when in water. For if fish inhale air from water by means of their mouth, why should not men and other animals do the same thing? They should inhale air from the mouth quite as much as fishes. If the latter have this power, the former should have it also. But as this is not true in the one case, it evidently does not hold good in the other. Furthermore, if fishes respire, why is it that we see them die in the air and gasp as if suffocated? It is not owing to lack of food. The explanation given by Diogenes is foolish. He says that fishes, when in the air, inhale too much air, and this is why they die, whereas in the water they inhale a moderate amount. But this should then be possible for land animals also. In point of fact, no land animal is suffocated by excessive inhalation. Further, if all animals respire, insects must evidently respire also. Many of them, however, seem to live when they are divided, not only when divided into two parts, but into several, as in the case of the centipedes. How or by what organ is it possible for these parts to breathe? The chief cause of the error of these writers was their ignorance of the internal organs, and also the fact that they did not grasp the truth of design in nature. For by asking to what end animals are endowed with respiration, and by making a test of their theory on the organs themselves, as e.g. on the gills and lungs, they would soon have discovered the real explanation. Chapter 4. Democritus makes the statement, it is true, that respiration produces certain effects in the respiring animal, viz., it prevents the soul from being expelled from the body. He by no means says, however, that nature, in creating this function, did so with this end in view, for he is on the whole like the other physicists and makes no application of any such causality. He maintains that the soul and heat have one and the same nature, viz., they are elemental spherical atoms. Consequently, when these are compressed by the force of the surrounding air, inhalation comes to their assistance. For in the air there is a large number of the atoms which he calls mind and soul. In the act of inhalation, then, and along with the entrance of the air, these atoms also enter, and by counteracting the pressure prevent the expulsion of the soul that resides in the animal body. It is for this reason that life and death depend upon inspiration and expiration. For when the surrounding medium by its pressure gains control, and the outer air is no longer able to enter and counteract this control, respiration in the animal becomes impossible and death ensues. For by death one means the departure of these physical atoms from the body due to expulsion by the surrounding medium. The reason, however, why death necessarily comes at all to every animal, and why it does not come at any chance period, but in the course of nature only in old age, a violent death is contrary to nature, he has not in the least explained. And yet, because this phenomenon occurs evidently at one period and not at another, it behoved him to explain whether it is due to an external or to an internal cause. Further, he has not a word to say regarding the origin of respiration, whether its cause is external or internal. And yet it is evidently not the external mind that comes to the rescue here, but the principle of respiration and of respiratory movement is due to an internal cause, and we are not to suppose that the force of the surrounding medium is any explanation. It is also absurd to think that the surrounding medium has at once the effect of extinguishing by compression, and on its entrance the opposite effect. The foregoing, in content and manner of statement, conforms closely to the theory of Democritus. If one is to regard as true what was said a while ago, viz., that not all animals respire, then we must regard the Democritean explanation of death as not universally applicable, but only to those cases where animals breathe. But even to these cases it does not well apply, as is evident from facts observed by all of us. For in warm weather, when we are more than usually heated, we have greater need of respiration, and we all breathe more rapidly. When, however, our environment is cool and contracts and chills the body, we hold our breath. This is the very moment, however, that the air from without should enter and prevent the soul's expulsion. In point of fact, it is the opposite that takes place. For when excessive heat is accumulated owing to its not being exhaled, that is the moment we need respiration, and inhalation is necessary to this. The truth is, men breathe rapidly when they are hot, because respiration has a cooling effect at the very moment when, according to the theory of Democritus, they would be, to use a proverb, quote, adding fire to fire. Close quote. End of chapter 4. Recording in memory of Mitchell Edwards. Chapter 5 of On Respiration in Parva Naturalia by Aristotle, translated by William Alexander Hammond. This LibriVox recording is in the public domain. Recording by Geoffrey Edwards. Chapter 5. The theory of circular push described in the Timaeus gives no explanation whatever of the way in which heat is maintained in animals other than man, whether the preservation of heat in the various animals is due to the same or different causes. For if the phenomenon of respiration is found in land animals alone, we must explain why they alone breathe. If, however, it occurs in other animals also, but by a different process, assuming that they can all respire, we must find an explanation for the difference in process. Furthermore, the whole manner of explaining the phenomenon is fanciful. For Plato says that by the issuance of hot air from the mouth, the surrounding air is pushed forward and is transmitted through the pores of the flesh, and rests at the point from which the internal hot air issued. These elements thus effect a complementary displacement owing to the fact that a vacuum is impossible. In the same way, the inhaled air in turn, when heated, is discharged, and the warm air within, issuing out through the mouth, continues this quote, circular push. Close quote. And so this process, which is inspiration and expiration, goes constantly on. The logical consequence of the theory is that expiration precedes inspiration, whereas the opposite is the fact, as the following proves. The two things are correlated phenomena. Now, man's last act is expiration. Consequently, inspiration must form the beginning. Further, the end which these processes, I mean inspiration and expiration, subserve in the animal body, is not taken into account at all by the philosophers who advocate this theory. They treat them merely as unessential phenomena. We see, however, that they are the master factors in life and death. For when a breathing animal is unable to respire, at that moment death ensues. Further, it is absurd to suppose that the issue of hot air through the mouth and the entrance of air again by the mouth should be observable by us, whereas the entrance of the breath into the thorax and its discharge should not be observable. It is also strange that respiration should mean the introduction of heat. Observation shows the contrary, for expired air is hot, whereas inspired air is cool, and when the atmosphere is warm, animals pant in respiring, and they draw their breath frequently because the entering air does not adequately cool them. Chapter 6. We must also reject the theory that the purpose of respiration is nutrition, which presupposes the feeding of internal heat by means of the breath. According to this view, inspiration is similar to throwing fuel on a fire, and expiration follows when the fire is fed. We again urge the same objections to this theory as we did to the theories enumerated above. The same process, or something analogous to it, should be found in all animals, for they all have vital heat. In the next place, the advocates of this theory should explain how heat is generated out of the breath. The whole view is fanciful. According to our observation, generation of heat is due much rather to food. A further consequence of their theory is that food is received and excrement discharged at the same orifice, which is not seen in any other instance. Chapter 7. Empedocles also has a theory of respiration, although he does not explain the purpose of respiration, nor does he say definitely whether all animals are endowed with respiration or not. In treating of respiration through the nostrils, he fancies he is dealing with the main factor in this process. He is here mistaken, for there is respiration through the windpipe, which leads from the chest, as well as respiration through the nostrils, and without a windpipe the nostrils themselves could not respire at all. Animals may even be deprived of respiration through the nostrils, and suffer no harm. But if the use of the windpipe is shut off, they die. In certain animals, indeed, respiration through the nostrils is employed by nature for the secondary function of smell. Although almost all animals are endowed with the sense of smell, they do not all employ the same organ for this purpose. On this subject, however, we have spoken elsewhere more in detail. Empedocles asserts that inspiration and expiration take place through particular veins, in which there is blood, although they are not entirely filled with blood, and that these veins are provided with channels that lead into the outer air, channels which are too minute for the admission of crass matter, but large enough for air. Now, the blood is so constituted as to move up and down, and after its downward motion the air streams in, and inspiration takes place. On its upward motion, expiration into the outer air ensues, a process which resembles what we observe in the clepsydra. Thus all things breathe, and breathe out air again. Long bloodless tubes the body's surface reach, and at their close-packed vents are nostrils fixed, pierced through, and so a passageway is cut for air, while yet the blood is hidden held. When yielding blood along these channels ebbs, then bursts the surging air with tempest's wave within. But when the blood rebounds, the air is then expired again, as one may see a child with smooth bronze water clock at play. Upon her comely hand she sets the tube, and dips it in the yielding water's sheen, of which no drop slips in the vessel's form. Upon the close-packed vents the air doth press within, until the maid her hand removes, and frees the urgent stream, which entrance makes, whose even flow drives back the yielding air. So too, when ere the water full free flow hath filled the deep bronze tube, and maiden hand the passage firm hath blocked, then doth the air, the eager outer air, the vents make fast, and hold in its restraint the inner stream, whose waters at the narrow gates complain, until the maiden lifts her hand. And now is true the converse of what was before. The air flows in, the water's equal stream flows out. Thus also 'tis with fluent blood that coursing through our limbs now hurries back to inner depths, and straightway air pours in with surging swell. Again the blood returns from its retreat, then forthwith yields the air, exhaled once more in nature's even course. These are his words on the subject of respiration. As we have already said, animals that visibly respire do so by means of the windpipe as well as by means of the mouth and nostrils. Now, if Empedocles is speaking of respiration in this sense, we must inquire how far his explanation harmonizes with the facts. Apparently, the facts contradict his theory. For in inspiration the receptacle is expanded like a brazier's bellows. Expansion, however, is naturally explained by heat, and by blood which takes the place of heat, but it is not explained by air in the theory of Empedocles. In expiration, on the other hand, contraction and collapse take place, as in the bellows, excepting that the cases are not quite parallel in this respect, viz. The bellows do not admit and discharge air by the same orifice, whereas in inspiration and expiration the same orifice is used. If, however, he is here referring merely to respiration through the nostrils, he is quite wrong. For respiration is not a function which is peculiar to the nostrils. On the contrary, along the passage near the uvula, at the extreme end of the roof of the mouth, part of the air passes here through the openings of the nostrils, and part of it through the mouth, and this applies equally to inspiration and expiration. Chapter 8. It was said above that life and the possession of soul are accompanied by a certain degree of heat. For even the process of concoction, by which food is prepared for animal life, cannot be accomplished without soul and heat. All this is effected by fire. Consequently, such a fundamental process as this must be situated in the primary region of the body, and in the primary organ of this region, and here it is that we must look for this elementary nutritive soul. This is the middle region between the orifice for admitting food and that for discharging excrement. In bloodless animals the primary organ has no name. In sanguineous animals it is the heart. The food out of which animal members are generated is the blood. The blood and blood vessels must have the same starting point, for the one, as vessel and receptacle, exists for the other. The originating point for these vessels in sanguineous animals is the heart. They do not traverse the heart, they all issue from it, and are attached to it, as is evident from dissection. Now, the other functions of the soul cannot be performed independently of the nutritive principle, the reason for which has been stated in the treatise On the Soul. And the nutritive principle, in turn, cannot subsist without natural heat, for it is through natural heat that nature has endowed the nutritive principle with warmth. Fire may be destroyed, as we said before, in two ways, by extinction and by exhaustion. Extinction is effected by opposing forces. Consequently, even when the fire is massed, it may be extinguished by environing cold, and when scattered, it is more easily quenched. This extinction by external force applies to animal heat as well as to inanimate fire. For animals die when dismembered by instruments or when congealed by excessive cold. Exhaustion, on the other hand, follows from excessive heat, for if the surrounding heat is great, and the internal supply of fuel is not maintained, the fire ceases to burn, not from extinction by cold, but from exhaustion. Consequently, there must be some cooling process if survival is to be attained, for this comes to the rescue and prevents extinction. Chapter 9. Some animals are aquatic, and others have their existence on the dry land. In the case of the very small and bloodless specimens of both classes, the cooling produced by their surroundings, whether air or water, is adequate to protect them against the above-mentioned extinction. For, being endowed with little heat, they need little protection. Animals of this kind are, consequently, in the rule short-lived, for a slight change on one side or the other destroys the balance. The longer-lived insects, which, like all insects, are bloodless, have a fissure just below the middle part in order that cooling may be effected through the membrane, which at this point is very thin. For, inasmuch as they have more heat, they have more need of cooling. Bees, for example, some of which live as long as 7 years, and the other insects that hum, such as wasps, cockchafers, and locusts, belong to this class. They produce this noise by their breath, as if by panting. As the natural breathing within rises and falls, it produces friction against the membrane in the middle region. For insects keep this region in motion, just as animals that breathe the outer air maintain motion by their lungs, or fishes by their gills. This motion is similar to what would take place if one should suffocate a respiring animal by holding its mouth, for then this swelling movement would be produced by the lungs. In the latter case, however, such motion is inadequate for cooling, although it is adequate in the case of insects. By means of friction against a membrane, they produce a humming noise, as we said, in much the same way as children make a noise through a perforated reed after stretching a thin membrane in it. And it is in this way, too, that the singing locusts produce their song. They possess greater heat than other varieties, and have a fissure in the middle region. In the songless locusts, this fissure is lacking. Sanguineous animals endowed with lungs that contain little blood and are spongy can live a long time without respiration, because the lungs are capable of great expansion, containing, as they do, little blood or fluid. Consequently, their own peculiar motion is adequate for cooling through a considerable period. Finally, however, it is unable to continue this, and without respiration it suffocates, as we said before. That form of exhaustion which consists in destruction through lack of cooling is called suffocation, and animals that die in this way are said to be suffocated. We have already remarked that insects do not respire. One can observe this plainly in the case of small insects, such as flies and bees, for they can swim a long time in a liquid, provided it is not too hot or too cold. And yet animals which have less strength require more frequent respiration. They are destroyed, however, and are suffocated, as we say, when the belly is filled with water, and the heat of the middle region quenched. From this we can understand how it is that such insects get up again after being covered for some time with warm ashes. We also observe that bloodless aquatic animals live in the air longer than do sanguineous animals that take in sea water, as the fishes. For the former have little heat, and consequently the air is adequate to cool them for a considerable time, as is the case with crustaceans and polyps. And yet it is finally inadequate for life, because they possess little heat. For even fishes are often dug out of the earth and found to be living, although motionless. Animals that are endowed either with no lungs at all, or with lungs containing little blood, need the least frequent respiration. End of chapter 9. Recording in memory of Mitchell Edwards. Chapter 10 of On Respiration in Parva Naturalia by Aristotle, translated by William Alexander Hammond. This LibriVox recording is in the public domain. Recording by Geoffrey Edwards. Chapter 10. In regard to bloodless animals, we have said that some of them owe their survival to the surrounding air, others to the water. In the case of animals that have blood and a heart, all those that are provided with lungs take in air and effect cooling by means of inspiration and expiration. Now, viviparous animals are provided with lungs, not those, however, that bear their living young outside of themselves. For the cartilaginous fishes are viviparous, but not within their own bodies. And amongst oviparous animals, those that have wings are provided with lungs, as e.g. birds, and further such animals as have scales, like the tortoises, lizards, and snakes. Viviparous animals have a lung well filled with blood, whereas most of the oviparous animals have spongy lungs. Therefore, as we said before, the latter need less frequent respiration. All of them, however, do breathe, even those that live and maintain their existence in the water, such as hydras, frogs, crocodiles, freshwater tortoises, tortoises of the sea and land, and seals. For all of these animals, and others similar to them, bear their young on the land, and sleep either on land or in the water with their mouths above the surface for respiration. Animals, on the other hand, that have gills are cooled by taking in water. To this class belong the cartilaginous fishes and other apodous animals, including all fishes. For their organs of locomotion are after the analogy of wings rather than feet. Amongst animals that have feet, only one, so far as has been observed, has gills, viz. The tadpole, as we call it. But no case has ever been seen of the possession of lungs and gills together. The reason is that the lungs are designed for cooling by the admission of air. Even the name pneumon, lungs, seems to have been derived from the reception of pneuma, air. And gills are designed for cooling by the admission of water. But only one organ is used for one purpose, and one method of cooling is adequate for each animal. And so, since we know that nature makes nothing in vain, and since one of these two organs would be useless, some animals are provided with gills, and others with lungs, but no animal with both. Chapter 11. Since every animal needs food for its subsistence and cooling for its persistence, nature employs for these two purposes one organ. And as in some animals the tongue is employed for the double purpose of tasting and communicating thought, so in those which are provided with lungs, the mouth serves for the mastication of food as well as for inspiration and expiration of air. In those, on the other hand, that have no lungs and do not respire, the mouth serves for the mastication of food, but gills are provided for cooling where cooling is needed. In what way the functioning of the aforesaid organs effects cooling we shall explain later. In order not to hinder the admission of food, a similar method is employed by respiring animals and by those that take in water. For in the former case they avoid respiring and swallowing their food at the same instant, otherwise they would choke by admitting liquid or solid food into the lungs through the windpipe. For the windpipe lies in front of the esophagus, through which food finds its way into the stomach. In the sanguineous quadrupeds, the windpipe is provided with a sort of lid called the epiglottis. In birds and oviparous quadrupeds, on the contrary, there is no such lid, but they attain the same end by contracting the windpipe. When food is being swallowed, the ovipara contract the windpipe, whereas the vivipara close the epiglottis. And after the food has passed, in the one case the windpipe is expanded, and in the other the epiglottis is opened, and air is admitted for the purpose of cooling. In regard to those animals that are provided with gills, they discharge the water through these, and then admit food through the mouth. They have no windpipe, so that they can suffer no harm by the wrong discharge of water into it, but only by the entrance of water into the stomach. For this reason, the discharge of water and the swallowing of food is done rapidly, and their teeth are sharp, and in almost all instances are serrated, for they cannot chew their food. Chapter 12. Regarding the cetaceous aquatic animals, such as dolphins, whales, and such others as have what is known as a spout organ, one might feel some doubt, yet even these conform to our theory. For they are apodous, and although they have lungs, they take in sea water. The ground for this apparent exception is given in the foregoing explanation. For the end to which they take in water is not cooling. This is produced in their case by means of respiration, for they have lungs. Consequently, they sleep with their mouths above the water's surface, and dolphins, it is certain, snore. Again, when they are caught in nets, they soon suffocate from lack of respiration. It is in order to breathe, then, that we observe them lying on the sea's surface. Since, however, they are forced to take their food in the water, they must on swallowing discharge the water, and for this reason they are all provided with a spout organ. When they have taken in water, they discharge it through this spout organ, just as fishes do through their gills. A proof of this fact is the position of the spout organ. It does not lead to any of the blood-filled organs, but is situated in front of the brain, and discharges the water here. For the same reason, the molluscs and crustaceans admit and discharge water. I mean the sea crayfish and crabs, as we call them. They make no use of it for cooling, for they are endowed with only a small amount of heat, and are in every case bloodless, so that they are kept cool enough by the surrounding water. But it is discharged on account of their food, viz., in order that the water may not enter at the moment of swallowing. The crustaceans, such as the sea crayfish and crabs, discharge the water through the plated folds along their shaggy covering. The purple fish and polyps discharge it through the hollow passage above the head. These questions have been treated with greater detail in the History of Animals. Concerning the phenomenon of the admission and discharge of water, we have said that it is due, in certain cases, to the need of cooling, and in others to the fact that aquatic animals are obliged to swallow their food in the water. Chapter 13. We must next describe the method by which cooling is effected in respiring animals, and in those provided with gills. We have already said that animals which have lungs respire. As to the reason why some animals have this organ, and why those that have it need respiration, it is because the higher order of animals are endowed with greater heat. At the same time, it must be that they are endowed with a higher order of soul, for such beings are of a higher order than plants. Consequently, animals whose lungs are more abundantly supplied with blood and heat are of greater bodily dimensions than others, and the animal that is supplied with the purest and most abundant blood, i.e. man, is the most erect of all animals, and his upper structure points to the upper region of the universe, true of him alone, because he has lungs constituted as we have described. The essential character both of man and of other animals must, therefore, be ascribed as much to this as to any other organ. This, then, is the purpose of the lungs. One must suppose that the material conditions and moving cause have constructed these animals in this way, as they have also operated to produce other animals with a different constitution. For some are composed chiefly of earth, like plants, others chiefly of water, like aquatic animals, and amongst the winged and terrestrial animals the one class is composed chiefly of air, and the other of fire, and they severally have their place in regions akin to their own natures. Chapter 14. Empedocles was wrong in saying that the aquatic animals are warmest and contain most fire, and, being defective in cold and fluid, they seek refuge from constitutional excess of heat in a medium to which their nature is opposed. For water is cooler than air. It is, however, altogether unintelligible how animals born on dry land can change their place of abode to water, for they are in almost all cases apodous. And yet, when speaking of their primary constitution, he asserts they are born on the dry land, and later leave this and migrate to the water. Again, our observation shows that they are not warmer than land animals, for some of them are absolutely bloodless, while others are almost so. But what kind of animals we should call warm, and what kind cold, is a subject itself that requires investigation. Regarding the explanation given by Empedocles, his contention is, in a certain sense, correct, although what he says is not entirely true. For it is true that regions and seasons which exhibit characteristics opposed to abnormal conditions in animals tend to preserve them, and yet their normal nature is best preserved in a place of abode similar to their own constitution. For the matter out of which animals are severally constituted must not be confounded with the varying states and conditions of this matter. I mean, e.g., if a thing were formed of wax or ice, its preservation would not be secured by placing it in a hot environment. For, owing to the opposed nature of its surroundings, it would be quickly destroyed, for heat melts that which consists of the contrary nature. Again, if a thing were composed of salt or nitre, nature would not carry it and set it down in a wet environment, for water dissolves substances of a warm, dry constitution. If, therefore, the fluid and solid constitute the matter out of which all bodies are formed, it is reasonable to suppose that fluid and cold structures will be found in a moist environment, solid structures, on the other hand, in a solid environment. Consequently, trees do not grow in water, but in the earth, although according to the same theory of Empedocles they should migrate to the water because of their being predominantly dry, or, to use his expression, predominantly fiery. This migration would be to water, not because it is cold, but because it is fluid. The natural constitution of matter, therefore, conforms to the environment in which it is found. The moist, e.g., is found in water, the warm in the air. Acquired conditions, however, are better regulated through an opposite environment, excessive heat through cold surroundings, and excessive cold through warm surroundings. For the environment reduces the excess in these conditions and brings them to an equable mean. This reduction is to be sought in an environment adapted to the particular constitution of the thing, and in the variations of ordinary climate. For acquired conditions may be opposed to the place of abode, but this is impossible in the case of the original constitution. Touching the theory of Empedocles that animals are divided into aquatic and land animals on the basis of differences in natural heat, and touching the explanation of the phenomenon that the one class has lungs and the other not, let the foregoing discussion suffice. End of chapter 14. Recording in memory of Mitchell Edwards. Chapter 15 of On Respiration in Parva Naturalia by Aristotle, translated by William Alexander Hammond. This LibriVox recording is in the public domain. Recording by Geoffrey Edwards. Chapter 15. The reason why animals with lungs can take in air and respire, especially such as have lungs well filled with blood, is to be found in the fact that the lungs are porous and filled with tubes. The lungs contain more blood than any other organ in what we call the viscera. Animals whose lungs are abundantly supplied with blood need rapid refrigeration because of the delicate balancing of the natural heat, and because the cooling process must penetrate through the entire interior owing to the great supply of blood and heat. Air can easily meet both these demands, for, owing to its rarity, it rapidly penetrates everywhere and effects cooling. This is not true of water. It is also plain from this why it is that animals which have lungs well filled with blood breathe best. It is due to the fact that the warmer the nature, the greater is the need of cooling, and at the same time that the air fills the lungs, it passes readily to the original source of animal heat in the heart. Chapter 16. The way in which a passage is made between heart and lungs must be studied through dissection and in the history of animals. Animal nature in general needs cooling because of the vital fire in the heart. This is accomplished by means of respiration, excepting in those cases where animals are provided with a heart only, but no lungs. When they have a heart but no lungs, as is the case in fishes, whose natural abode is water, cooling is attained by water through the use of the gills. In regard to the relative positions of heart and gills, one must study them ocularly in dissection, and their nicer philosophy in the history of animals. To give a summary description, however, the case is as follows. One might suppose that the position of the heart in land and aquatic animals was different. As a matter of fact, it is the same in both. For the direction in which the animal's head naturally inclines is the direction in which the heart's apex is turned. But inasmuch as the heads of land animals do not incline in the same direction as those of aquatic animals, the heart's apex in the latter case is turned towards the mouth. A sinewy, vein-like tube extends from the extremity of the heart to a central point where all the gills are united. This is the largest of all the tubes, but there are others on each side of the heart which extend to the several extremities of the gills, whereby cooling is produced and transmitted to the heart, the water being constantly piped through the gills. The rapid swelling and falling motion of the thorax in inhaling and exhaling air serves the same purpose in respiring animals that the movement of gills does in fishes. Respiring animals suffocate in a small quantity of air that remains unchanged, for each medium, water as well as air, soon becomes hot, and contact with the blood heats them. When, however, the blood becomes hot, the process of cooling is impeded. Also, when respiring animals become unable to inflate their lungs, or aquatic animals to move their gills, whether owing to disease or to the weakness of old age, their end must be at hand. Chapter 17. Birth and death are phenomena common to all animals, although there are specific differences in their modes of occurrence. Death is not everywhere the same, although in its varied forms there is a common element. Death ensues from violence or from the ordinary course of nature. Death is violent when due to an external cause, natural when due to internal processes. The latter conforms to the original organic structure and is not an adventitious condition. In plants, this process is called decay, in animals, senility. Death and decay attach to all organisms alike that are complete, and to the incomplete also, but in a different way. Under incomplete, I understand such things as eggs and seeds of plants which as yet have not taken root. Death is caused in all things by lack of heat, in complete organisms by its failure in that part where the vital principle is lodged. This principle is lodged, as we said above, in the middle region where the upper and lower parts are conjoined. In plants it is the point at which stem and root unite. In sanguineous animals it is the heart. In bloodless animals, in an organ analogous to the heart. In some of the bloodless animals we find many vital centres potentially, though not actually. For this reason, certain insects when divided continue to live. and such sanguineous animals as are not highly organized live a considerable time after the removal of the heart, as is true of tortoises. Tortoises continue to move their feet so long as their shell is not removed, because their organization is of a lower order, resembling in this respect the insects. The vital principle succumbs in its possessor when the heat, which is its accompaniment, is not reduced by cooling. For otherwise, as we have often remarked, it is consumed by its own agency. When, therefore, the lungs or gills, respectively, become hardened or dried up and earthy through lapse of time, it is impossible for these organs to function, to dilate and contract. And finally, when a further demand is made upon them, the fire of life is extinguished. Consequently, death quickly ensues in old age, even on the appearance of trivial ailments. This is due to the fact that there is little heat left in old age, most of it having been exhaled in a long life, and if any extra strain is put upon the lungs, life is speedily quenched. For the fire within, being now but a tiny feeble flame, is extinguished by a slight movement. That is also the reason why death in old age is painless, for death comes to the aged with no element of violence in it. Rather, the dissolution of the soul occurs quite without their feeling it. Diseases which make the lungs hard, whether by tubercles or deposits, or by excessive morbid heat, as in fevers, produce an acceleration of the breathing, because the lungs are incapable of full expansion and contraction. And finally, when motion is no longer possible, men exhale their breath and die. Chapter 18. Birth, then, is the original suffusion of the nutritive soul with heat, and life is the maintenance of this heat. Youth is commensurate with the growth of the primary organ of cooling, old age with the wasting of the organ, and the prime of life with the middle period between the two. Death and violent destruction mean respectively the exhaustion and extinction of the vital heat, for it is destroyed from both causes. Exhaustion is given in the nature of the thing itself, and is caused by lapse of time and by the completion of a normal term of life. In plants this is called decay, in animals death. Death in old age is due to the exhaustion of the organism that comes from senile inability to effect cooling. We have now explained the meaning of birth, life, and death, and have treated the causes of these phenomena in animals. Chapter 19. From these considerations, one may clearly see why it is that respiring animals are suffocated in water, while fishes are suffocated in the air. For in one case cooling is effected by the medium of water, in the other by that of air, and both of them are deprived of this by the change in their place of abode. We have further to explain the movement in gills and lungs respectively, exhalation and inhalation in the one case, and the admission and discharge of water in the other. We have also to explain the structure of the organ of respiration in what follows. Chapter 20. There are three phenomena regarding the heart which might be supposed to have the same nature, but are different, viz., palpitation, pulsation, and respiration. Now, palpitation is a compression of heat in the heart, owing to cooling in other parts of the body produced by excretion or waste, such as we see in the disease called palpitation of the heart, as well as in other diseases, and in fear also. In fear, the upper regions of the body are cold, and their heat is discharged and collected in the heart, where palpitation is caused, and the heat being thus compressed into a small space, it sometimes happens that animals are suffocated and die from fear and its morbid conditions. The phenomenon of pulsation, however, that occurs in the heart, and which, as we see, is a constant process, is similar to the throbbing in an abscess. In the latter, the movement is painful owing to abnormal change in the blood. This process continues to a point where the blood is concocted and converted into pus. The condition is analogous to boiling. For boiling takes place when water is evaporated by heat, and it bubbles up owing to its increase in volume. The development of abscesses is arrested when the pus is not evaporated and the liquid becomes very thick. The process in boiling is arrested when the confining vessel is overflowed. The supply of moisture derived from food and its expansion through heat produces pulsation in the heart, the expansion extending to the heart's outer covering. And this is a constant process, for the flow of fluid to the heart, out of which the blood is generated, is constant. It is in the heart that blood is first formed. One can observe this plainly in the growth of an embryo, for before the veins are distinguishable, the heart is seen to contain blood. Pulsation, for this reason, is more marked in youth than in old age, for the process of evaporation is stronger in youth. The blood vessels all pulsate, and they do so simultaneously, for they are all connected with the heart and originate in it. The heart, however, is in constant motion. So too the blood vessels are in constant motion, and simultaneously with each other as long as the heart moves. Palpitation, then, is a reaction in the heart due to the compression of heat by the cooling of other parts of the body. Pulsation is the evaporation of the moist element as it becomes heated. Chapter 21. Respiration is due to the increase of the heated element in which the nutritive principle is lodged. As all other bodily elements need maintenance, so does this element of vital heat, and even in a greater degree than the others, for it is the source of maintenance for the other elements. When it is increased, it necessarily expands the organ in which it is found. One must conceive the structure of this organ to resemble a brazier's bellows, for neither lungs nor heart differ very much from a form such as is illustrated by a bellows. Both are double. The nutritive principle must be situated in the centre of the vital power. The lungs then increase and expand, and by expanding, the part in which they are lodged must also expand. We see this when we respire, for the thorax is then expanded because the inherent principle in this part is expanded. Owing to this expansion, as one sees in the bellows, cold air must be introduced from without, and by its cooling effect, the excess of internal heat is lowered. But just as the organ was expanded owing to the increase of heat, so now it necessarily contracts when the heat is diminished, and by contracting, the air which was inhaled is again discharged. Air that was cold when admitted, but warm when discharged, owing to contact with the heat inherent in the organ, especially in the case of animals whose lungs are well filled with blood. The air enters through a mass of pipes, canals as it were, with which the lungs are provided, and blood vessels extend alongside each of these pipes, so that the entire lung appears to be filled with blood. The admission of air is termed inspiration, and its discharge expiration. The process of respiration is continuous, so long as life and this organic motion continue. Life, therefore, is given in the processes of inspiration and expiration. The movement of the gills in fishes is produced in the same way. For by the expansion of the blood's heat in its course through the members, the gills are lifted and water passes through. When, on the other hand, the heat retreats to the heart through the channels and cooling is effected, the gills are lowered and the water passes out. The expansion of the heart's heat is constant, and its readmission when cooled is constant, and so in animals provided with lungs, life and death are ultimately conditioned by respiration, and in fishes by the admission of water. This, then, is a statement of our views of life and death, and of almost all the questions germane to them. It is the province not only of the physician, but also of the natural philosopher, up to a certain point, to discuss questions of health and disease. We must not, however, forget how these two classes of men differ, and how they regard a subject from different points of view, although experience shows that both professions are, to a certain extent at least, conterminous. For the better educated and more painstaking physicians are conversant with the laws of nature, and deem it correct to derive their principles of practice from this source, while the best trained philosophers of nature almost always conclude with a discussion of the principles of medicine. End of chapter 21. End of On Respiration, and end of Parva Naturalia by Aristotle, translated by William Alexander Hammond. Meta-coordinated by Joe. Proof listened by Guedo. Read by Jeffrey Edwards. Recording in memory of Mitchell Edwards.